Hey, what is up everyone? It's Caleb from Caleb's Video Maker 2, and welcome to your first video in your series over SQL Server. Now, we are going to be covering a lot of information in this series, but to start, let's just talk about what SQL Server is. SQL Server is what's known as a relational database management system. There are many different kinds of relational database management systems. The one we are going to be talking about in this series is known as Microsoft SQL or SQL Server. Now, SQL Server is a database management system that can cost money, but there are free versions. So that's great. I'm going to be using that one, so you guys are welcome to join me on that. Now, what is a database? A database's job is to store data. Now, I know that's pretty obvious from the name, but let's get a little bit more specific. What is data? Basically, data is anything we want to store and use at a later date. Oftentimes, databases are used for businesses. That way they can analyze data and make business decisions off of that data. For example, if you're talking about sales, right? You can calculate what items are selling the most, how much is selling, what price are they being sold at, who's buying them. All of that information can be calculated from data that is stored inside of a database. So using data within a database, we can get a summation of how our business is going. There's other uses too, not just for analyzing data, but often databases are used to power applications. So if you have an application here, often there will be a back-end database. And then when the user puts information into this application, it will get stored in a database. Then the next time that user uses the application, it's going to get the data from the database and present it to the user. So databases are often used for websites, when you sign in, when you create user accounts, when you purchase stuff. All of that data is stored inside of a database. That's because the application itself does not change. The code used to create this application stays the same. You can run this application over and over and over again, and the only thing that changes is the data. So there's a separation between the application and the data that powers that application. So hopefully that gives you a pretty good summary of what a database is. Now, as we go on, obviously we're going to get a little bit more specific, but this is just a good overview. You can think of a database as something that stores a ton of information, then we can analyze that data, and we can use that database to power an application or to just make our lives a lot easier with storing information. So we covered the DB inside of this acronym, Relational Database Management System. But what does the R mean? That means relational. What does that mean? Well, a relation is basically a fancy word that means table. Quite fancy. So a table is drawn as a square, and then we have columns listed across this way. And we'll often give column headers. So for example, we could say first name, last name, phone, email. Then an individual row will fill out that information. So one person will put in his first name, his last name, his phone number, and his email. And you can continue to store more and more and more people inside of this table. So it's kind of like an Excel spreadsheet. But there are a lot of differences between a database and Excel. So now we need to discuss, why would you want to use a database over something like an Excel spreadsheet or just a text document and so forth? So there's many different ways we can store data. For example, there's Excel. There's something known as comma separated value, and that's just values, comma, values, comma, values, comma. There's text files, and then there's things like databases. Now each one of these has an application. You don't always have to use a database for everything, but there are some specific situations when you want to use a database. One of the first reasons, if you're comparing databases to like Excel, for example, is that spreadsheets are usually all or nothing. And what that means is if you have multiple columns inside of this table, inside of an Excel sheet, you can't say, oh, we're going to let this column be viewed and this one, but I want this one to be private and this one to be private. That's not something you can easily do with an Excel spreadsheet or any kind of spreadsheet. But with a database, you can select just certain columns from a table, and then these ones can be private. Along with that, SQL Server supports roles. So a role is essentially a title you give a group of people that says what they are allowed and not allowed to do. So you can have administrator and then some other roles in there. And that's going to allow them to do certain things with this database. That's contrary to Excel, where you would have to make different files and edit the file permissions. It's a whole lot easier with databases because you can just say, oh, anyone with this role or this person can do this, but anyone else is not allowed to do this. It's a lot more intuitive. It's a cool word. Intuitive. So back to this table. If we're in an Excel sheet and you just want this column to be presented, that's not something you can easily do. But with SQL Server, that's a piece of cake. All you have to do is say something like select, and then say, let's say this is the phone number, for example. Then you could say phone number, and then say from, and then say whatever the table name is. So we could say users. And then the only thing that's going to be returned is this column. So these ones are not even going to be shown. Along with all of this, databases are more secure. They're easy to back up, they're easier to recover, and overall it's just a better way to protect your data. If you're just working at a small little company and you need to store a little bit of information, an Excel sheet might be fine. But if you're talking about enterprise applications, there's no way you will ever use a spreadsheet for that kind of stuff. Nearly any time you're working with an application that needs to work with data, you're going to want to work with a database. And finally, the last reason I could conjure up is that you can store a lot of information inside of a database. We're talking terabytes, petabytes, a lot of information. You can have a table with millions of rows and still have a functioning database. Where if you try to store that much information in a spreadsheet or a text file or a comma-separated value file, you're gonna have really, really bad performance and probably mess everything up. That's one of the biggest reasons people use databases, is they're designed to store a lot of information. Now there's so many different types of database management systems out there. Why would you want to pick SQL Server? Well, there's a couple of reasons. One is that SQL Server is owned by Microsoft. Now I know some of you people absolutely love Microsoft and some of you hate Microsoft, but regardless, if you're working with, for example, the .NET framework, which that is basically the infrastructure you build apps on when you're working on the Microsoft platform, it's very easy to integrate with SQL Server. You can use other database management systems when you're working on the .NET framework, and you can also use SQL Server for other applications, for example, Java applications. But in general, when you work with a company that works with the .NET framework, they will use a SQL Server backend. That's just so everything is owned and managed by the same company, Microsoft. Now there are some competitors to Microsoft. For example, there's MySQL, there's Oracle Database, and there's a few other relational database management systems out there. Now where does SQL Server stand in competition to these two? Well, I would say it's somewhere right in the middle, if you ask me. Oracle, on the other hand, is usually considered to be like super up there, like enterprise level. And MySQL is kind of considered to be user level. Now, I might be generalizing a little bit too much because in reality, you could use probably any three of these for any application. So if you're working with an app that is small but might get large and still needs to manage a lot of data efficiently, SQL Server might be the best choice for you. But even if not, I have videos over both of these topics, so my recommendation is just learn them all, and then you're going to know the differences between them, and you're going to know which ones are right in which situations. Well, that's about all I got to say about SQL Server in this video. Hopefully that gave you a really rough overview of what SQL Server is, and I know this had a lot of information in it. If it's a little overwhelming or if you're just completely new to this topic, what I would recommend is just to keep watching this series, as we're going to be breaking down more and more information about SQL Server and learning some of the SQL commands. And at that point, you're going to start grasping things, and all of this information is just going to make sense. So if you've liked this video, please click like, be sure to subscribe, and I will see you all in the next video where we will be downloading SQL Server. Thanks, guys. Yo guys, welcome back. In this video, we're going to be downloading SQL Server. So now I'm just going to search it because, you know, URLs change all of the time. We're going to be using SQL Server 2016, but we're going to be looking for the Microsoft.com website. And then here's the URL as of now. And then we go to downloads. Now here we are shown different versions of SQL Server, and the one we're going to be looking for is Developer Edition. And what this is a fully featured free edition. So that means we can do everything. Now, if you want to actually do this in production, you might want to consider the Express Edition. And that one is basically a slimmed down version, but the benefit of that is that it's free for production. So obviously we're just learning, so I'm going to go with the Developer Edition. Now it's going to ask you to sign into your Microsoft account. If you don't have one, it's really easy to make one, so I'm not going to go through that whole process. Alright, so we're here. Now when it's your first time opening this app, you'll have to agree to kind of like a license agreement or whatever in order to join Visual Studio Dev Essentials. Now I already did that, so it's not showing that for me. Essentially, that's going to give you access to all of these panels here. But the one we are most interested in is Microsoft SQL Server. So we're going to click download on that. That's going to start the download. All right, let's open that. Yes. Now, of course, you're going to be presented with even more options. We'll go with basic just because, you know, that's the easiest one, but if you want, you can customize things. Yeah. Whatever. I totally read that. Yep. And there we go. Now it's going to start downloading a bunch of junk. Just let it do its thing and come back in a little bit. Alright, so it's done. Now they're actually working on a release of SQL Server that works on Linux and Mac OS. So if you guys want to give that a try, I would encourage you to do that and let me know how it goes. And all of this stuff that popped up is pretty important, so I'm going to actually copy all of that. And I'll just use a tool known as the snipping tool. Shablam, and then you can just save that. It says a restart is required, but basically everything is installed. Down here it says install SSMS, and that's what we're going to be talking about in the next video, but for now, let's click this Connect Now button. And you can see here we are now connected to our database. So I think we can do stuff like select 5 plus 5, for example, and then type in go. There we go. But I don't really like working with the database in this command prompt kind of thing, so I'm going to be installing a visual tool. Now we're still going to be learning SQL. I'm just going to be typing the SQL inside of this visual tool. So I'm not teaching you guys the cheating method, doing everything visually. We're going to learn SQL in this series. We're just going to be typing it into a different tool known as SSMS. Or SQL Server Management Studio. So that's what we're going to be talking about in the next video. Be sure to check that out, guys. If you've liked this series so far, please be sure to click like, subscribe, and share it with all your friends and everything like that. Thanks, guys. Hey, welcome back, everyone. It's Caleb from Caleb the Video Maker 2. And in the last video, we talked about installing SQL Server 2016. And I said the next step was to install SSMS, or SQL Server Management Studio. But before we do that, I wanted to talk a little bit more about what we already have installed. So once you install this database, there's a cool tool you can use. If you open your Start menu and go to All Apps, you will find something known as SQL Server 2016 Configuration Manager. Now within this tool, you can do all kinds of configurations, but one of the ones I wanted to point out is under on the side here, SQL Server Services. So services are things that run in the background on your computer. So, for example, when we start up our computer, it's automatically going to start our SQL Server database, and it's just going to continue running as we are using our computer. To see all of those services, you can go to the Start menu and type in Services, open that, and if you scroll through here, and you can see we have SQL Server right here. And there's actually two types. There's Microsoft SQL Server, and then SQL Express. SQL Express is basically a smaller, slimmed down version of the full SQL Server that you can use free for production. Here you can stop the service and start it again, but you can also do the same thing in the SQL Server Configuration Manager. So up here we have SQL Server, and we'll go to the full version, and right here you can right click, and for example, we can restart it if for any reason we need to restart the server. So that is how you restart your SQL Server if you ever need to do that. But let's put that down for now, and let's click Install SSMS. We will go with this one right here, as that's the most stable release. So we're going to give this a run, and it's really simple. I mean, you guys probably don't need a whole lot of help learning how to install things, but I just want to make sure I cover all grounds so that way no one's lost, no one has no idea what's going on. I want to make sure we're all on the same page, so once we start studying this in the next video, we can just go through it and not hit a bunch of walls. So we're gonna have to let this install, and it might have to go through and install a bunch of other stuff. We'll just let it do its thing, and we'll be back in just a little bit. All right, so it's done. Close that, and now we can open up all apps. And here's the shortcut, Microsoft SQL Server Management Studio. I'm gonna pin that to the start menu so I can find that. And now let's open that. When you first open it, you're going to need to connect. So I connected to localhost, and where did I get that from? Well, when we installed it, there was a bunch of information that popped up at the end, and that was part of it. That's why I took a snapshot of it. So you can see here, localhost. So this is the app we are going to be using to type our SQL statements. Now to actually write some SQL, we go to the new query. And we can do anything in here, such as select 5 times 5. And it gives us the result, 25. So over here inside a localhost, you can see our databases here. And within each database, you're going to have tables and a bunch of other good stuff. We'll be getting into all of that in the upcoming videos, but I just wanted to make sure you guys get this application running because that is what's important for the upcoming videos. If you, by any chance, have another server you want to connect to, you can click this little green button over here, and you can type in whatever you need over here. So as you can see, I just connected to the dot, which is another way to say localhost. You can see in here, we're gonna have the same databases. These are all called panels, and if you, by any chance, screw everything up, there is a way to reset your panels to the default. So all you gotta do is click Window and then Reset Window Layout. And there you go. So I think that's enough to get you all started. Obviously, there's a whole lot more to learn, but on the bright side, we're not going to have to figure out how to install everything again. We got that done, so now we can start working on actually studying SQL statements. So thanks, guys. Be sure to check out the next video, and I will see you then. And as always, please be sure to click like and subscribe. Welcome back, everyone. Now, if you want to be extreme success in databases, you need to speak the right language. And I ain't talking no SQL or any other fancy programming language. I'm talking terminology. And what I mean by that is it's important to know some specific terms so that way when you communicate with other experts in the field, you know what they're talking about. You don't just want to be like, you know, that one thing that one guy talked about that helps things be unique. I forget what it's called. You don't want to be like that. So I think it's important to know some of the most common terms. Just studying these terms alone will help you get a better grasp of databases, how to structure them, how to make them, all of that good stuff. The first term you should know is data. Not data, that seems pretty simple, but we're going to get gradually more complex. Data is facts, information, anything you want to store for later use. When we collect a bunch of data, it's known as a database. So think of data as information and a database as a collection of a bunch of information. Now when we have a database, we need a way to interact with that database. And that's where a database management system comes in. Now the database management system is a software that allows us to use the database. SQL Server is an example of a database management system. Now, the distinction between all of these terms is kind of cloudy, so often people will use things interchangeably. So, someone might say, oh, SQL Server is a database. Don't be like, psh, no, it's a database management system. Just because they're so similar that there's not fine lines between these terms. In fact, there is another type of database management system known as a relational database management system. Now the R in this word stands for relational. A relational database presents our data in tables. Essentially, the database management system's job is to take data that could be scattered on the computer's hard drive or solid state drive and present it in a beautiful way. So let's go classic, we'll go with the hard drive. Let's say this is the hard drive, right? And you have data just stored all in this thing, right? Well, you want to look at this data in a certain way. The database management system will take all this data and present it to you in a nice, beautiful table. That's what a relational database management system is. SQL Server is also a relational database management system. But not all database management systems are relational. So if you had this circle that represents databases, this might be relational databases. All relational database management systems are database management systems, obviously from the name, but not all database management systems are relational. For example, we still have all of these ones out here that are not relational. Now, the important thing to take away from these words is relational. That's a fancy word that means table. Now, what exactly is a table? Well, you can think of it as a square, and this table is going to have a name, and inside of the table there's going to be columns. So each column is going to have a header of what that column is called. So it really depends on what the table is about. But you could have a table to store recent orders, for example. So the name of the table might be orders, and the columns might be like order ID, date ordered, who ordered it, stuff like that. Now this is just an example. As to how to actually structure this data, that's something that requires database design, which we'll talk about that in upcoming videos. But let's just say this is the perfectly designed table, and we want to store information in this table. That's where the term row comes in. So a row is a record of information that goes this way and gives a value for each one of these columns. Now this is a really bad example of the kind of data you would store in here, but essentially every single purchase is going to be entered into this table as a row. So this would probably be called the purchases table, and every single row would be an example of a purchase, or you could think of it as an instance of a purchase. So we could have another one in here with the ID of 8. This guy bought a house, $300, cheap house. Who bought it? The guy with the ID of 112. Date purchased. So the two key words here you really need to know are column and row. There are a few other terms you will come across, including record. A record is essentially another name for a row. You'll also hear the term field, which I use that to represent one value within a column. And you can also hear that called a cell. There's a lot of different terms that you need to become familiar with. Now, when you are inputting data into this table, sometimes you will leave a field blank. For example, we can have the ID of 10 stuff. We could have them buy a poodle. And the poodle costs $300,000. Who bought it? The dude with the ID of 96. But the date purchased, we don't put that information in. When we do that, that is called a null or a null. A null is essentially the absence of a value. So I'll just continue my list down here. Some people think nulls are acceptable, some people don't think they're acceptable, and it ultimately depends on what column it's in. For example, having the stuff null would be not okay because it's a purchase. How can you have a purchase without buying anything? And even in this situation, the date purchased would probably want to have a value every single time. So making those decisions of what's allowed to be null and what's not allowed to be null brings up the idea of database design again. Now, for those of you who've seen my other series, you know I really focus heavily on database design. So the start of my series are almost all identical because we go through the whole database design process. But I find that it's very, very, very important because your database design decides how your database is going to work. What kind of tables are we going to create? What are we going to store in those tables? What are we going to name our tables? What columns have what attributes? All of that information is decided by our database design. And the database design helps us to protect data integrity. Now, I'm not going to write that one because that's actually the term we are going to start with in the next video. So thanks, guys. Hopefully all of this information was somewhat useful. These are beginner terms, so you're going to come across a lot more as you go on. But it's very important that you understand this foundation and have it in your brain. So thank you guys for watching. I really appreciate it. Be sure to click like and subscribe. And as always, I will see you in the next video. Hey, welcome back to your SQL Server tutorial series. Now, in this video, we are going to continue our discussion of different terms you are going to come across when we're working with databases. Now, the very first term we are going to start with is known as data integrity. What is data integrity? Essentially, data integrity means the data in our database is correct, as up to date as possible, and describes what we are trying to describe. How good is a database if the information is confusing, it's not up to date, we have conflicting data, or we have missing data. All of that stuff is going to make our database a pain in the butt to work with. So data integrity is something we strive for to prevent things like that. We don't want duplicates, we don't want conflicting information, we don't want missing data, we don't want data that you can't associate with what it's trying to describe. And that's a big thing that a lot of people don't think about. That's because it doesn't seem like it's going to happen, but it is actually pretty easy to come across when you have a bunch of data, but you don't understand what is that data trying to express. What is it talking about? So this brings up two important terms, entity and attribute. So an entity is a pretty cool word to describe something. So an entity is something. Yeah, super vague, not helpful, I know. But it helps if we go through an example. In the last video we talked about a table that represents sales or purchases. So in that situation, the entity is the sale. This is going to be the table name. So we have a table. We can name the table either sale or sales, and every single row is an example of a sale. So the entity in this case is the sale. The attributes are the columns. This is a pretty good start when it comes to database design. That's because we already have the entity as the table name and the attributes as the columns. That way we always know what the data is describing. Each row has data for each column, and that data describes that sale. But what happens if you try to store every single thing in your database in one table? Well, in that case, it's going to be a really super long table, and we're going to have a ton of columns. And we might have columns that are unrelated to the sale. For example, one of our columns might be customer, right? And then all of this data might be describing the customer. Now, when you grab an individual row and you take all of this data, how are you supposed to know what is describing the sale and what's describing the customer? See what I'm saying now? This is going to sacrifice, I said that weird, this is going to sacrifice our data integrity. Now we are going to discuss data integrity in depth in future videos, but just to start off, one way you could really improve the way your database is structured is separate tables by entities. Sales are an entity, customers are an entity. So why not split this table, have two separate tables, one for sales and one for customer. That will bring our data integrity back. Now it's best to start with data integrity because it's easier to start with it than try to force data integrity on already bad data. If your data is already bad and you're trying to improve the data integrity, you have to go and correct a bunch of garbage. But if you're starting with a database that enforces data integrity, you don't have to worry about those issues. Now I'm going to remove the customer table here, but we're still going to focus on the sales for a little bit. We have the sales table and we have all of these columns describing these sales. And let's say we have two rows inside of this table. One here and one here. And these are describing two individual sales. I'm working on my drawing skills. I know they need improvement, but it's a work in progress. So this guy made two purchases at this store. And one, he bought a car. The other one, he also bought a car. And he just happened to buy the same kind of car. So we might have the person who bought it, okay, let's say his ID is 7. He made two purchases, and he bought a car. And as we get into more specific database design, we'll get a little bit more specific with our data. But for now, car's fine. And this car might be a certain model or something, but anyways, the data is the same for both of the rows. How do we distinguish this row from this row? This brings our data integrity into question. To fix this, we need to introduce something known as a primary key. A primary key is a column that can force every single row to be unique. If we don't have a primary key, we don't know if this is two purchases by the same guy purchasing two of the same things, or is it one purchase accidentally put into the database twice? Ooh. We can't really tell. So we need to introduce something known as a primary key. And this can distinguish different rows. So for example, we could give this an ID of 1 and this one an ID of 2. Or if you don't want to use just random numbers or IDs, you can find something that you can use in the real life to distinguish these things. For example, the cars might have some kind of item ID or something like that you can use to distinguish, oh, these are two different cars, they just happen to be the same model. Now we're getting into a ton of detail that we don't need to go into right now. That's because the focus of this video is database terms, not how to design a whole database. So might be going a little off topic, and because of that, I'm going to end this video here. In the next video, we're going to be talking about some of the more advanced terms you might come across. So I will see you then, guys. Thanks for watching, and as always, click subscribe. Oh, don't forget to click like. Hey, what's up everyone? Welcome back to your SQL Server tutorial series. Now, I'm going to keep this one short, because I got to go eat some grilled cheese. But let's get started. The very first term that I'm going to introduce to you in this video is foreign key. Now, a column inside of a table can be labeled as a foreign key. And when you do that, you're telling the database that every single row for this column has to have a value that is in a different column. It's much easier to visualize, so let's draw that out. Here we have two tables, and let's say we label this column as a foreign key, and we say that it references this column. That means every single row inside of this table has to be a value inside of this column. So for example, let's say this is 8, 12, 10, and 11. The accepted values here would be any of these, but 13 would not work because it's not in this table's column. The reason we create foreign keys is to create relationships in our database. Relationships are when two tables are connected somehow using a foreign key. Now, almost always, a foreign key is going to reference a primary key. So in this situation, this would be the PK, this would be the FK, primary key, foreign key. And the foreign key references the primary key. Now, both the primary key and the foreign key are known as constraints. A constraint is something that prevents certain data. In this situation, we are preventing the value 13 because it's not a value in the parent table. That is a perfect example of a constraint. Now, constraints are a very important thing when it comes to protecting our data integrity. Now, there are numerous constraints. Primary and foreign keys are just examples, but there's some other options that you can use. We will be getting into all of the constraints in upcoming videos. Now, when you create a primary key, it's automatically indexed. When a column is indexed, we can select data and use that column much faster. Literally, just think of like an index in a book. It helps you find information much faster. Primary keys are automatically indexed. Foreign keys, on the other hand, are not automatically indexed. We'll often be using foreign keys and primary keys together, so it's usually beneficial to manually give the foreign key an index. And we'll get into the details of indexes too in future videos. But this is kind of like a video just to kind of give you a feel of everything that's going to be coming. That way when it comes, it's not, bam, here's a bunch of new information. Yeah. Another thing regarding foreign keys is that when you're referencing another column, both of the columns have to have the same data type. Put simply, a data type is just the type of data. There are a couple different categories. We have numeric data. That would be a number. We have string data. Then we have what some people call temporal data, and that's just dates and times. Then there's a couple of other data types that don't really fit into these categories. A data type is used to tell the database how to work with our data. So this is completely different than this. In this situation, this is numeric data, and this is string data. String data is essentially data that is enclosed in quotes and is just a sequence of characters. So a number is an example of a character. So a string is alphanumeric, and that means alpha as in alphabet and numeric as in numbers. But they don't work like numbers. When you store this as a string, you're not planning on doing math with these numbers. This is a number in the database, therefore you can do math stuff with it. Math stuff. Temporal Those are dates, and we'll get into all of those details later. But just so you guys have a rough overview, there's three main categories: numeric, string, and temporal. Memorize those. Now, when you're talking about database constraints, you don't usually mean data types because that's kind of like a separate topic, but you can kind of think of them as constraints. Because if you labeled a column one of the numeric data types, and you tried to put something in like pi, that's going to be rejected. So a data type is another way to protect our data integrity. And you can see all of this comes back to data integrity. The most important thing in your database is data integrity. Because of that, the upcoming videos are going to discuss data integrity, database design, relationships, normalization, all of that good stuff. Check out the next videos. If you've enjoyed these, if you've been learning, please click subscribe. It really helps my channel and it means a lot to me too. Be sure to click like, and I will see you in the next video. Now with some mighty fine grilled cheese. And now I'm back. So, what are we talking about today? We're talking about relationships. Straight up dating advice from Caleb the Video Maker 2. Here it is. Good luck. That's all I got. Psych, guys, you know what I'm talking about. Database design relationships. Oh man, that joke never gets old. So we are going to be talking about 1-to-1 relationships. Now there are three types of relationships: one-to-one, one-to-many, and many-to-many. And we are going to dissect all of these in the upcoming videos. And each one has a certain way you're supposed to design it. Therefore, I think it's appropriate to separate them out into their own videos, so that way I'm not overwhelming you. I thought I could discuss all of this in one video one time, and the video was 30 minutes long, so I decided it's probably good to, break things up a little bit. So let's go through an example of a user and a username. And just to follow the whole theme of relationships, let's go for an animal dating site. No kidding, I thought of the most ridiculous example, and I planned a whole series around it. And then I looked it up, and these things actually exist. This might actually be practical for something. Anyways, this website, animals can go on, and obviously they might need some help from their owners, but they can create an account, they'll have a username, and they can date other animals. So a user has a one-to-one relationship with a username. Now this is talking about database design relationships. The username is exclusive to the user, meaning that if your username is sexy chick 123, get it? Because it's an animal dating site, chick, and then this, I can't draw a chicken. This is the chicken that this username is referring to. There is a level of exclusivity here in that this chick doesn't have two usernames, and this username does not have two chicks that it's describing. Now, let's compare a one-to-one relationship with a one-to-many relationship. In this, we're going to need a new design. So we are going to start with a blogging website. So let's say this dating website also has blogs, right? And you can post your blogs on there. Now this blog post posts the author's name up here. So this chick, this is the most ridiculous example ever. This chick can write multiple blogs. But in this situation, each blog can only be written by one individual. In that situation, this would be a one-to-many. We will discuss one-to-manys in more detail in the upcoming video, but essentially, there is only one side that has exclusivity, meaning that this blog is exclusively authored by one person, animal, individual, entity, whatever. This one too, it just happens to be the same animal, but it could have been a different one. It has one author. Now until the next video, let's disregard one-to-many relationships and let's focus on how to design one-to-one relationships in a database. One-to-one relationships are the easiest ones to design. That's because you only need one table to do it. This brings us back to the terms entity and attribute. In this situation, the entity is the user and the attribute is the username. So we can just have a user table, and one of the columns could be the username. Now this forces every user to only have one username. That's because when we enter a new user, we'll put a row, we'll give it one username, and then the next user is going to have one username, and there's no more columns for another username. So a one-to-one relationship, you can just think of it as an attribute describing an entity, and you can store the attribute as a column within a table that describes the entity. So for this situation, we would have sexy chick 1, 2, 3, and then all the other data about sexy chick 1, 2, 3 can go over here, and a new user would be a new row with only one username. Now there is one other way you can store a one-to-one relationship if you want, and that's to break something off into a new table. So an example for this might be an image. Let's say a user can have one image, and that image is used for their profile. This image could be placed into a new table called images. And what this will do, it will separate the images from the user just a little bit, and then this images table is going to have a foreign key that points back to the user. What's the benefit in this? Well, it actually just allows some separation. You might not want all of the images in the user table just because you don't think it's relevant, or you don't want it stored there, or you're just trying to make things faster, anything like that. Now, you only need to use the images table when you need an image, not all of the time. If you store the image inside of the users table, like right here, that data is going to always be inside of that users table, regardless of whether you want to use the image or not. And that's just an example. Either way would work. You could put it in the table, you could make a new table for it. It all depends. If you really want a table separate for images, that would work fine. The only thing to remember here is that in order for this to be a one-to-one relationship, there only needs to be one image per user. That means if you have a foreign key, every single row would have to be unique. So you'd have like 6, 8, 9, and then if you gave the value 6, that would be 2 images pointing to the same user. This would no longer be a one-to-one relationship. So to enforce that, you need to use a unique constraint, and we will talk about that in an upcoming video. But as for that, that's all I got for one-to-one relationships. Hopefully that was helpful. As always, please click subscribe, support this channel, and I will see you in the next video. Hey, welcome back everyone to your SQL Server tutorial series. This video we are going to be oh, my throat Welcome back everyone to your it's not Oracle. Welcome back everyone to your SQL Server tutorial series. Oh gosh, really? Claire! Welcome back everyone to your SQL Server tutorial series. This video we are going to be discussing one-to-many relationships. The last video we discussed one-to-one relationships, and we briefly mentioned one-to-many relationships. The example I gave in that video was a blog posting website. So we're creating a website where people can write blogs about themselves and their lives or whatever. And we made it to where a user can write as many blogs as they want. But that blog is exclusively owned by that one user. So this chicken wrote a couple blogs, and in this situation, the blog is exclusive to this chicken. This is the perfect example of a one-to-many relationship. The reason this is a one-to-many relationship is because if you take one of these, let's say users, and then you compare that to these. So you would say, one user can have many blogs, but then you take one of these and compare it to this. So you say, one blog can be owned by only one user. This is the easiest way to figure out what kind of relationship we have. See, we have one user can have multiple blogs, but one blog can only have one user. If this said multiple users, then it would be a many-to-many relationship. That's what we're going to talk about in the next video. But for now, let's focus on one-to-many and learn how to design this in a database. Before we dive into the actual way to design this, let's go through some incorrect ways to design this that are common amongst improperly designed databases. This is the first incorrect way to design a one-to-many relationship. As you can see, we have the blogs as an attribute of the users. So you can think users as the entity, and then we have blogs as the attribute. And then you would just store the content of the blog inside of this column. So Caleb Curry posted a blog about me, and then I told my life story. Why is this a bad thing? For one, it doesn't give us separation of the attributes for the blogs. For example, this is the blog title, so we might think, oh, let's separate that out a little bit. Let's say blog title. And we'll make a new column, blog content, and then you could say whatever you wanted, and you can just store it as a string. This is also bad though, because now we are actually storing this as a one-to-one relationship. That's because we can only have one blog in here. So how do we add a blog if we did it this way? Well, we could say, let's just throw a comma in here and put the next blog name. So now I have two blogs, my life, and then we'll just put a comma or something to separate the contents, and then we'll write the next blog. Well, that is also just really bad because these values are no longer atomic. They're not their smallest indivisible pieces. If you had it this way and you did something like select everything from users, the blog title would be returned as just a comma separated list. So you'd have, and this is just awful. Now we don't know if this is one blog with a comma or if it's two blogs. It's just really bad design. So a way around this, let's add even more columns. So we could say blog title 2 and store that, and then you could have a blog content 2. But that's also really bad because now we're limited to 2 blogs. And plus, if someone only has one blog, that means all of this blog 2 stuff is going to be null. Wasted space is stupid. Don't do that. Now let's go on to the third bad way to do this. And that would be to actually add a row. So we would say Caleb Curry, and we would put the second blog in here. And in this situation, it's really not that bad because we only have one username column. But if we had some other attributes of the user in here, for example, we could have their phone. Well, now we have their phone number in here twice. This is just really, really bad because now we have redundant data. Bad. You just don't want to do that. So the 3 ways you don't store this is comma separating your values, adding extra columns, or adding rows with redundant data. 3 bad things you don't want to do. Now let's talk about the correct way to do this. Let's go back to just one blog. Accidentally erased it. And what we need to do is we need to take this blog and separate it out to its own table and name it blogs. Now in this situation, we would have a reference to the user, which in this case we could have a foreign key to the username, or we could use an ID if you wanted. And then we would have a column for the title and a column for the content. And that would work just fine. And now if you needed to add another blog, you would just add a row. So we'd have the first row, Caleb Curry, and then the about me in the title, and then the blog content right here. And then when you need another one, you just add a row, another reference to Caleb Curry, another title, another blog content. As you can see, my drawing is awful. But in this situation, we don't have another column here that says phone, so we don't have redundant data. So let me just erase this and kind of make a cleaner version of this. Could have a users table, and one row could be like 7. Then we'd have the blogs table, kind of a blog ID, title, and content. And then each blog gets an entry inside of this table and is associated back to one user. So we could have user ID of 7, blog ID of 1. That would be one blog. Then if we had another one, it'd be 7, 2. That would be another blog. And you can see we don't have any redundant data. That's because the blogs table has the bare minimum required to describe a blog. If we stored the blogs in here and we added rows, we would have the username repeating, we would have the email repeating, and that's just not good at all. And one of the important things to remember here is that in a one-to-many relationship, you're going to need a foreign key. So in this situation, we have the user ID. This is a foreign key up to the user ID primary key in the users table. You could just as easily make this username and reference the username. It doesn't really matter as long as there is a way to associate it with one user. So that's that, guys. That's a one-to-many relationship. It's a little messy, I know. This is designed more for conceptual understanding, and once we start building databases, we will actually, program this crap. So Hopefully by then, this will be a little bit more clear. And that's all, guys. So please be sure to subscribe, click like, and I will see you in the next video. Hey, what's up everyone? It's Caleb from Caleb the Video Maker 2. This video we are going to be talking about many-to-many relationships. In the previous two videos we talked about one-to-one relationships and one-to-many relationships. And the example we used was a blogging website. We had a users table and a blogs table, and the blogs table referenced the users table. That is how we allowed multiple blogs to be written by one person. In that situation though, a blog could only be authored by one person. So you could kind of draw it like this. User has a one-to-many with blog. Blog is on the many side. What if we wanted to alter this app though, so that a blog could have many users? Then it would look like this. The way we did it without the many side for the user is we had the blog table reference the user. Well, if we wanted to do the many side on this side, all we would have to do, right, is have the user table reference the blog table. But then there's a problem, because now we have a table referencing another table, and it gets really messy. For example, if this is the table, and let's say we just have different rows in these tables. Each line we could say is a user, and each line we could say is a blog. So this one user could have wrote numerous blogs, and this user could have wrote numerous blogs. And then you could also think of it the other way. This blog was written by this user and that user. So as you can see, it just kind of gets messy when we start working with a lot of data. The solution to this is to break this many-to-many relationship into two one-to-many relationships. So then what we are going to have is the users table with a one-to-many, and the blogs table with a one-to-many. But how do these connect? Well, we're actually going to have another table inside of here to fix this conflict. Imagine that this disorganization is a conflict, and we need someone to kind of break in and separate the fighting entities. So we are going to name this user blogs. By convention, I'm having the first one singular and the second one plural. It will look something like this. This table is known as an intermediary table, or a junction table. Essentially what this table does is it records the associations between the users and the blogs. So anytime a user has a blog, it's going to be listed in this table. So let's put some simple data in here. Let's say we have a few users and we have a few blogs over here. And we'll just write some IDs, let's say 6, 7, and we'll have another person down here. So these are the 3 users inside of the users table. And we'll have 3 blogs over here too. And we'll give them all IDs. Now anytime there is a user authoring a blog, that association is going to go in this user's blog table. So let's say this guy right here, he authored these 2 blogs. All we would have to do is for every blog he's associated with, is create a row. The columns in here are going to be the IDs. So we could say 6, 7, and then we have another row, 6, 12, and that shows the combination of this user with these 2 blogs. If you want to reverse the thinking a little bit and say blog users, you can do that too, but in this situation it's not quite as clear. That's because on the application, a user creates a blog. It's not so much the other way where a blog creates a user. That's why I decided to put users first, but if you wanted, you could flip these tables and do it the other way. You could say blog authors, for example, and you would have blogs and then the users table over here. Any way you want to design it is fine, as long as there's only 2 one-to-many relationships. In this situation, we have a one-to-many this way and a one-to-many this way. That's because we have only 1 6 here, but we can have as many 6s as we want here. Same for this side, we can have the blog 7 one time here, but we can have as many references to blog 7 as we want here. So for example, this lady could work on the blog with the ID of 7, and now we have 2 references to the blog with the ID of 7. So that is your introduction to intermediary tables and designing many-to-many relationships. You are always going to want to break many-to-many relationships up into one-to-many relationships. Hopefully that is all clear for you guys. Hopefully you enjoyed the video. If you're enjoying this content, Please click like, subscribe. What's coming up next? Well, I think I'm going to do an overview of all of this, not to be redundant, but just to kind of wrap it all together and express the 3 different ways to design tables. And that will just kind of make it more concrete in our minds before we move on. So thanks guys, I will see you in the next video. Bye. What is up everyone? It's Caleb from Caleb the Video Maker 2. This video is going to conclude our conversation on relationships. We've discussed 3 relationships: one-to-one, one-to-many, and many-to-many. These are the 3 types of relationships you are going to come across when we're starting to work with data. The important thing to know is how to design each one of these. We've talked about these in detail in the last 3 videos, so the purpose of this video is not to teach you how to do it, but to conclude it all and make sure you get all of it in one video. So if you don't know what I'm talking about, make sure you go watch the previous 3 videos. The first one, one-to-one, there's 2 ways you can design this. The first is the simplest. All you gotta do is put a column inside of a table. Problem solved. The reason that is if something exclusively describes an entity, you can just use it as an attribute of that entity. So when we have an entity, and we have all kinds of attributes about that entity, you can say that these attributes have a one-to-one relationship with the entity. That's because they're exclusive to that entity. The example we gave was a username. A username is not repeated by multiple people, usually. In the example we gave, it was not repeated. That means one entity can have one username, and a username is exclusive to one entity. The other way to store a one-to-one relationship is actually in another table with a column that references the primary key of the parent table. So we had the user table, and then we had a pictures table. And this was for a profile picture, and the picture was exclusive to a user. So if we had the user with the ID of 7, that pic would reference that user. The column that stores that user ID would have to be labeled unique. That's required if we want to maintain a one-to-one relationship. If you don't put unique, that's fine. It's just now going to become a one-to-many relationship. Speaking of one-to-many relationships, here is how you design them. You will have a column in another table that references the parent. You're not going to want to label it unique though, like I just said. That would force it to be a one-to-one relationship. If we did that, it would look like this: entity, attribute. But what we want is entity to multiple entities. But one of these is exclusive to that parent entity. And the way we do that is by having a foreign key. Think about it. If we have a foreign key column, and you only have one row to describe this entity, for example, you can only give one value for that foreign key, which means this would be the only parent for that child entity. We haven't discussed a whole lot on parent-child relationships, but essentially when you have a foreign key referencing a primary key, that's what's known as a parent-child relationship. The primary key would be the parent. So anytime you have a foreign key referencing another column, even if it's not a primary key, that foreign key is the child of a parent-child relationship, and the column it references would be the parent column. That's why I don't use erasers. If we want to have a many-to-many relationship, we need 3 tables. The middle table is what's known as the intermediary table, and that is basically the table that allows us to store a many-to-many relationship in a database. The connection between these 2 tables are both going to be one-to-many, and the many side is going to be in the middle. So we could have users in blogs. And then inside of the intermediary table, we would have user blogs. Perfect. So that sums up how to design each of the 3 relationships. Now, this brings up a question that I've been having, and I wanted to ask you and see what you guys thought. Let's say you have a users table, right? And one of the columns in here is first name. And we have 2 users inside of this table. One with the ID, here, let's add an ID. One with the ID of 7 and one with the ID of 8. And let's just say, by chance, both of their names are Caleb. Is this a one-to-one relationship, or is it a one-to-many? This is a very good question, and it's important that you understand why I'm asking this. Because you think about it, we have the name Caleb, and it's being used by 2 people. That's one way to think about it. And if you thought about it this way, it would be a one-to-many relationship. The other way to think about it is you have 2 people and they just happen to have the same name. In this situation, it would be a one-to-one relationship. And in general, when possible, you need to go this route. It seems slightly confusing because we have the same thing twice. You'd think it'd be a one-to-many relationship. But you have to think about what a one-to-many relationship is. A name is used to uniquely define a human being. It just so happens that some people's names repeat. Therefore, because the name system is not designed as a one-to-many, it would be a one-to-one with some repeating data. And that's okay that that data is repeating because they're two separate names, they just happen to be the same. It's kind of confusing, I know. But let's just think about it if it was a one-to-many relationship. How would we store this? Well, we would actually need a names table. So we would have something like first name, and inside of this table we'd have IDs and values. And then inside of this table, instead of having the first name, we'd have the first name ID, and we would replace Caleb with 22. But this is just a really bad design. Even though it's connected all nice with foreign keys, it's just dumb because we're only going to have such a small minimal amount of repeating data if we have redundant data like this. Because then think about it, if someone comes and joins our app, and let's say their name's Amy, they are going to have to create a new row inside of the first name table because it doesn't exist. And overall, this is just a really dumb design. So if you're looking at it and there's only going to be occasional repeating data by chance, and the column itself is not designed to be like a list of things you can choose from, then I would stick with the one-to-one relationship design. More examples of things that would be one-to-one would be a phone number. Even if two people by chance had the same phone number, maybe they share a phone. Another example would be last name, and I'm sure there's a couple of others. You can also apply this to other kinds of examples. This is a user table example, but this could be applied to a comment table, for example. If we had a comments table, and we had two comments that just happened to have the same exact comment, like, great, would that be a one-to-one relationship? I would vote yes. That's because the comment value, or what the comment says, is not designed to be a one-to-many. It just so happens that they have the same value. So I know I kind of went on a rabbit trail with all this, but this is some important stuff to think through. What are the proper ways to store data? That's an important thing to ask yourself. Thank you guys for watching. Hopefully this content was helpful. If you've enjoyed it, as always, click subscribe, click like, and why not go watch the next video? It's going to cover something useful, and I'm sure it will be fun, and you guys will like it. So, see you then. Welcome back everyone to your tutorial series over SQL Server. I'm Caleb from Caleb the Video Maker 2, and this video is going to start our discussion on data integrity. Now I know we've been going over tons of conceptual stuff, but I see this as all foundational to creating databases. So instead of diving in and coding stuff, if we take a step back, focus on the concepts, when we go and code stuff, everything is going to be a lot smoother, a lot more fun, and just all together better. So that's why I focus so much on this stuff. And trust me, data integrity is one of the most important things in our database. What is data integrity? Data integrity is something we strive for. We want to have data integrity. Data integrity is essentially a word that means our data is correct, up to date as possible, not conflicting, no duplicates, and is describing what we think it's describing. Now, we categorize data integrity into 3 categories. That's just to make it a little bit easier to think about. The first is entity integrity, the second is referential integrity, and the third is domain integrity. I'm going to take one video to discuss each one of those, and that'll give you a good foundation of everything regarding integrity. So let's start with entity integrity. Now before we dive into all the depths of entity integrity, let's first focus on what is our goal when we store data. And that goal is to follow the rule of 1. Oh, Black, did you hear that? Blacky. You may also hear this as atomicity, or things being atomic. And essentially everything is supposed to describe one thing. Even if we have a table called books, this here, even though it's plural, is describing one type of thing. This is known as the entity type. We wouldn't want this table to describe books and CDs. That would be breaking our rule of 1. So that's the first thing we want to do. Get rid of anything that's breaking the rule of one. If you want to store CDs, that's fine. Just put it in a different table. But in general, if we get more specific, it's a little bit easier to work with the data because we know all the data is describing books. Now, each row describes one individual book. Each column describes one thing about that book. In addition to that, we should only have one record per book. So over here is my beautifully designed book, and we want to store that in our books table. First, it would probably have an ID, maybe a name, an author, and ISBN maybe. I don't know. Anyways, you can store any book in here. The thing that's important is that we only have one row to describe that individual book. Now you also have to consider, is this table describing individual books, like books at a library, for example? Or is it describing individual books that have been created or published? For example, if we had two of these books, would they both be inputted into the table? Or would it just be inputted into the table once because it's both the same book? That's kind of a design concept you're going to have to wrap your brain around. And it's not a huge issue in this video because we're just starting with the basics. But let's just say every single book gets a row. So we can put this book right here. This works out great because we have this ID. But let's say we got rid of that ID. We might have a table and it'll have a title, author, and ISBN. And this is very simply designed. Often you would take the authors and put them into their own table. But this is like a very simple example. And you have this book in here twice, right? Well, since it's the same book, the data is going to be exactly the same. So that brings up the question, do we have one book in the table twice? Or do we have two books that are different, both in their one time? It's kind of a confusing question, but it's important to understand why we are asking that. If we had to ask that with real data, we would be in a situation where we do not have good data integrity because we don't know what this data is describing. Is this describing one book or two books? I don't know. That's where the primary key comes in and saves the day. So if we add a column onto this and we label it as primary key, that is going to enforce every single row to be unique. And when we have a primary key, we should be able to expect that every single row is talking about a new book. The reason the primary key is so helpful is because it's both unique and not null. Why is it important that it's unique and not null? It's because that is what is required to force every row to be unique. So entity integrity revolves around primary keys. That's what it's about. To get entity integrity, you need to make sure every table has a primary key. Now, if you don't know what to use as a primary key, just create one. Say, whatever the table's called, let's say books, ID. So simple. If you're trying to store books, give it an ID of books ID. Boom. That simple. Now that's an example of a surrogate key. Surrogate means computer generated, no real world meaning. This book might have an ID of 9, but that means absolutely nothing in the real world. It's not related to the ISBN, it's not related to anything. It's just a computer generated number for the sake of the database only. That's in contrast to a natural key. A natural key is something that has real world meaning. For example, this library might give every book they ever get a code, and they could use that as the natural key. The only things that are very important is that the key is unique, not null, and in addition to this, it never changes. I mean, think about it. If we had this book with the ID of 8, and then one day it changed to 9 or 10, is it a new book, or is it the same book with a new ID? That's confusing. That throws our integrity into question. So you gotta make sure all of these three things are met when you're using a primary key. And if you're using a surrogate primary key, it's super easy. Natural keys can change, so it's a little confusing. Natural keys are more likely to change because they have real world meaning, but they should still never change if they are labeled a primary key. So much chalk. So yeah guys, I know all that was kind of confusing. It's a bit messy, but that's because database design is a messy, confusing topic. There's a lot of questions you have to ask yourself, a lot of things to consider, and there's just a lot of questions you don't think about until you start designing a database. That's why I've been focusing so heavily on data integrity, so you guys understand, and when we start creating databases, I can just create them and I don't have to explain every single thing, like, oh, what the heck is this foreign key? Why are we labeling this unique and not null? And why is this primary key? And why is there 3 tables? And all of that stuff. So this is like the foundation. Don't neglect it. It's important, and it's going to help you in your database career. So thanks, guys. As always, click subscribe, click like, and I will see you in the next video. Welcome back, everyone, to your SQL Server tutorial series. I'm Caleb from Caleb the Video Maker, and we are going to be continuing our discussion on data integrity, specifically referential integrity. We've talked a lot about foreign keys and primary keys, and we haven't even got to the video devoted to them yet. That's because they're so fundamentally important to designing a database. When we create a foreign key that references another column, we are creating what's known as a relationship. And another word for relationship is a reference. Think of a foreign key as referencing another column. That means referential integrity is something we need to consider whenever we create foreign keys. Now, a foreign key has to reference a column that is unique. So this would include the primary key and any columns labeled unique. We'll be discussing how to do all of that stuff in syntax when we get to that, but for now, just think of it conceptually. All that is saying is that every single row for a column has to have a unique value. That way, every single row is a specific entity. That goes back to the last video where we talked about entity integrity. That's a prerequisite to referential integrity. Now, we can make foreign keys in our head and not actually code out saying, hey, this column references this column. In that case, we still have references. The only problem is we're not enforcing references in the database. So that means we have a table over here and a table over here, and this table references this table, but we're not allowed to draw the arrow. It's divided from the parent, and you just have to assume or hope that all the data in here is correct, which the chances are it's not going to be if you're not using the right referential integrity rules, which we will discuss in just a moment. So for example, we might have an entity over here with the ID of 8, and we might reference that over here, and then this entity gets deleted. Well, guess what? This still exists, and when you look up 8 over here, nothing exists. Did 8 exist at one point, or did we just make up the number 8 on accident? What's going on here? And you're not able to go into the table structure and see that this column references this column or anything, because it doesn't. All you did was say, this column references this column in your head, but you never actually coded it out. That means you could throw a number in here like 138, and 138 doesn't even exist in this table. Nothing is forcing this relationship. All you are is putting data in 2 tables and trying to make them match. Some people create entire databases without ever using foreign keys. I don't know how that's even possible, but essentially in that case, you're just going off of the numbers and hoping that they match. It's like asking for something to go wrong in your database. When you're in that situation, you are sacrificing referential integrity. That's because you can't promise that this reference is actually referencing anything, because there's no connection. Even if there does happen to be 138 here, there's no association. They're just 2 values in 2 different tables. And then you yourself associate them in your mind. But we don't want to do things in our minds because we're humans and we make dumb mistakes. Computers are more predictable. So even though we can join these and basically create a generated table, the problem is they're not connected in any way in the database's eyes. So you can delete this, you can change this, it's all fine, it doesn't matter. This one is separate, it doesn't have any connection to that one. So how can you fix this? Well, obviously you need to define a foreign key. When you define a foreign key, you are telling the database, hey, this references this, or this column references this column. And when you do that, it's telling the database only to allow values that exist in the other table. So if I came in here and wrote 1337, but that didn't exist in this table over here, it'd be like, no, noob, that doesn't work. It's gonna pwn you. So just creating a foreign key is one step to protecting your referential integrity. Now, foreign keys have a couple of settings you can configure, and we'll get into those in detail when we talk about foreign keys. But essentially, we need to tell the database what happens when we delete the row that's being referenced, what happens when we update the primary key of the row that's being referenced. All of those kind of things we need to ask. We also have to consider things like, is the foreign key labeled not null? Is it unique? Making sure you have all of these constraints set up correctly are how you protect your referential integrity. And this is not a concept I can discuss entirely on a chalkboard. This is something we are going to have to code in SQL Server. This is more of an introduction so you understand the concept of what referential integrity is, so then when we start discussing all these things, it's not a slap in the face like, what? Don't obsess over it. We will get into the details. So if you want to make sure you see those videos, be sure to click subscribe and you'll get notified, hopefully, when I create new videos. If you like this video, be sure to click like, and as always, I'll see you in the next one. Oh, and this should say not null. Hey, welcome back everyone to your video over SQL Server. I'm Caleb from Caleb the Video Maker 2, and we are going to be covering domain constraints. This video is going to be pretty simple and to the point. That's because a lot of this information we've covered in the other videos coming up to this point. I'm just going to leave all this information here though, in case you need to come back and look up what a domain constraint is, or you just forget and you need to review. So before we talk about what domain constraints are, we need to talk about what domain is. The domain of something is the appropriate or accepted values. How do we know what's acceptable? This comes from what's known as the business rules. Now there's a fine line between business rules and domain, so don't take it all too seriously and try to divide one, just learn them both. But essentially, business rules are the English or spoken language equivalent of domain. So your boss might be like, hey loser, do this or you're gonna get fired. And then you take his commands and convert that into domain. So he might say, yo punk, we need to restrict this data from here to here, nothing higher, nothing lower. And your response is to convert that into domain using SQL. Now SQL Server is awesome when it comes to domain constraints. That's because we can get very specific on what data is allowed, and it's very easy to do. We'll talk about how we can do that in just a moment. But first, let's talk about some of the more general ways we can restrict data. Obviously, we can use data types. What that does is force the data to be inputted in the database to be of a certain format. That means if it's a numeric column, it's going to reject string data. We will cover the data types in an upcoming video, but just understand what they are for now. The other way is using constraints. So we could say the unique constraint and the not null constraint. Unique is going to force every single value for a column to be unique. Not null is going to say every single row has to have a value for that column. So we can use these to be a little bit more strict on what's allowed. So let's say a value has already been entered of 17, for example, and that column's labeled unique and you try to put 17 in again, it's not going to let you do that. Or if you don't put a value in at all and it's labeled as not null, it's not going to let you do that either. These are the general ways how to restrict data. But SQL Server has something known as a check constraint. Now a check constraint allows us to be very specific on the data that is allowed. So this allows us to do things like between. And then you can satisfy your boss by restricting the data to be between two certain numbers. That's really super cool. One of the other common database management systems, MySQL, does not have check constraints. So you gotta go an extra step and add database triggers or find some kind of workaround to make this work. So all of this is a way to protect our domain integrity. I wrote constraints up here, but more generally, this should be integrity. And then these are examples of constraints we can use to force domain integrity. Making sure we have the right data type and the right constraints, as well as all of the specific check constraints, is really all we're going to need to make sure our domain integrity is being a-okay. That really sums up everything I gotta say in this video. If anything is confusing, I'm probably gonna have videos over each one of these things, so you can go check all those out. So hopefully that was helpful. As always, be sure to subscribe, and if you've enjoyed this video, please click like. Thanks guys, and I'll see you in the next video. Stop. I have a tongue mark on it. But there was a mark on it I licked off, so we're good. Welcome back everyone to your series over SQL Server. I'm Caleb from Caleb the Video Maker 2, and in this video we are going to discuss primary keys. Now, before we start, I had a question for you. Have you ever ordered like some really delicious food and you eat about 90% of it and there's about 10% left over for leftovers? And it frustrates you because 10% is just enough to make you want more and not satisfy you. You're probably wondering, where is this going? Well, throughout the series, I've kind of sprinkled some primary key stuff, so you've gotten a couple pieces of pizza here and there, but now this is the whole pizza. I'm basically putting it all together in one video so you don't have to look through the entire series to find all the details on primary keys. That means a lot of this might be review, but it's all in one spot, so it's a good review. Now, a primary key is a column that is added to a table that allows every single row to be uniquely identifiable. What that means is that every single row has to have a primary key. Not null means that nulls are not allowed. Null is just the absence of a value. In addition to the primary key being not null, every single row has to have a unique primary key, or else it wouldn't be able to uniquely identify one of the entities. That means the primary key also has to be unique. You can basically think of the primary key as a combination of not null and unique column attributes or constraints. Lastly, the primary key should never change. There's actually a way in SQL Server to force the primary key column to never allow changes. We will discuss that in just a moment, but for now, let's just think about why. Why is it that the primary key should never change? Within a table, we have a couple columns. It doesn't matter what they are. Let's just say one's a string and one's a number. And then we add a primary key column. So we'll just use a number. So we'll say ID, and this will have the ID of 7. So you can tell that this ID points to a specific entity. This one right here. Ooh, squeaky. But now we go ahead and change this 7 to an 8, just for some reason. Now this brings confusion because we don't know if the 8 is talking about a new entity or it's the same entity with a new number. You might think, well, obviously it's the same entity with just a different ID, but maybe it's not so obvious. It's obvious in this situation because we manually changed the number. But if you're just looking at data, you might not have that memorized or know that ahead of time, and it might be a little bit confusing. Especially when there's conventions that the primary key should never change, and then you see a change like that, your first thought would be that it's a new entity, because primary keys don't change. Therefore, since this one has an 8, must be a new entity. Additionally, there are two categories of primary keys: surrogate keys and natural keys. Surrogate keys are just computer-generated numbers. Often this will be some sort of ID. The reason we do this is that it automatically makes it super easy to make the column not null and unique, and actually it's pretty easy to make it never change. Natural keys, on the other hand, have real-world meaning. They are a column that stores actual useful information, and these columns have to as well be not null, unique, and never changing. Because of that, natural keys are usually a bit harder to come up with. It takes a little bit more thinking, but as a result, you'll often have data that's easier to read because you don't have all of these IDs everywhere you have to connect. Whether you use surrogate or natural keys, that's up to you. I'll probably be using mostly surrogate keys. That's just because I think it makes it easier to make things work. Natural keys can also work well too, it just might take an extra level of thinking. And it's also important to understand that these are categories that we use to make it easier to discuss primary keys, but the database does not know the difference between these two. It's not like you create a primary key and say, oh, this is a surrogate one. Oh, this one's a natural key. You don't do that. You just use primary key keyword. So when you create the database, you're going to say primary key, and you are going to use this right after you create that column. And once we get into the create table statement, that's going to make a whole lot more sense. But that's literally all you have to do. You don't have to say, oh, primary key surrogate or anything like that. So to summarize, surrogate keys are almost always IDs. Natural keys are something that can uniquely identify a row, but have real-world meaning. For example, an email address. Oftentimes, you'll want to use either surrogate or natural keys throughout the entire database, rather than switching to surrogate for part of it and switching to natural for part of it. Because then it's kind of confusing because you don't know which tables are using surrogate keys and you don't know which ones are using natural keys unless you dive in and look through the columns. If you're just starting out with database design and you're not required to use natural keys for some reason, I recommend starting out with surrogate keys. That's because it's super easy to make the database create your IDs for you. You don't have to worry about the data changing or anything like that. Now, the way we protect the data from never changing is we use what's known as an identity. Now, an identity column is a column that automatically gives you a new number every time you insert a new row. Each table can have up to one identity. Also, a table can only have one primary key. Because of that, it often makes sense that the identity column is also the column labeled as primary key. It does not have to be that way though. You can actually have an identity on a different column. That would only really make sense though if you're using a natural key and you still needed a column that counts for you. In addition to counting, the identity will also prevent you from changing the data. So that is how we protect this one rule of never changing. We make sure that the column is labeled the identity column. When we start talking about primary keys, the concept of indexes needs to come up. Because we've already covered a lot of information and we still have to cover indexes, I'm going to break this up into two parts, and in the next video we will be discussing indexes relating to primary keys. So thanks guys for watching this video. Hopefully it was helpful. If you have any questions, just leave a comment. I'll try to help out, or someone else can leave a comment and reply. Be sure to click like, subscribe, and as always, I'll see you in the next video. Thanks guys. Welcome back everyone to Caleb the Video Maker 2. This video is going to continue our discussion of primary keys inside of SQL Server. The first thing we're going to talk about is something known as composite keys. Then we'll go into indexes related to primary keys. But first, let's just start with the composite keys and get through that first. Now, what is a composite key? A composite key is a key or a primary key that consists of multiple columns. So more than one column. It doesn't have to be two, it can actually be more than that. So you could have a primary key consisting of 10 columns if you wanted, I think. I don't think there's a limit, but you guys can try it and let me know if there is. When would you want to do this though? You would need to do this if one column is not enough to make an entire row unique. Let's go through a little example that shows this in action. We have a table. So we'll go with the bare minimum number of columns just to keep it simple, but you could have much more data in here if you really wanted to. But to start off, we'll name this class students, and over here we'll have the class ID and the student ID. Now for a specific class, let's say the class with the ID of 7, it has the student with the ID of 3084. Could we use either of these columns to uniquely identify every single row? Well, as we have it now, no, we couldn't. That's because multiple students can take a class. So we could have 7 and then 3072. Now the class ID is repeating. So we couldn't use the class ID to uniquely identify each row. That's because there's repeating values. So if I said, oh, grab the one with the ID of 7, you wouldn't know which row to grab. So what about the student ID? Let's think about the same thing. Can a student take multiple classes? Yes. So that means we might have this student again, 3084, but this time taking a different class. Now we have repeating student IDs. So if I said, grab the row with the student ID of 3084, you wouldn't know which row to grab. So the student ID also will not qualify as the primary key. In this situation, a composite key is actually a really good thing we could use. Essentially, we're going to combine these two columns as the primary key. Now these are actually going to be foreign keys pointing to different tables, so we'll probably have a class table and a student table. And when we have two keys inside of a composite key, it's actually known as a compound key. But often people will use the terms composite, compound interchangeably, so don't worry about it too much, but I just thought I'd let you guys know that. If we made both of these IDs a composite key, the combination would have to be unique. So 7 and 3084 could only be in there one time. So then I could tell you, hey, grab me the row with the class ID of 7 and the student ID of 3084. And you would know it's always going to talk about this row. That's because we're not allowed to have repeating data. This would not work. Now you might also be asking, is it really necessary to use a composite key? Couldn't we just have another column right here and make it something like class students ID? And then every single row would have a new ID, so we'd have 1, 2, 3. And then you wouldn't need to say 2, you could just say 1. Grab me the row with the class student ID of 2, and you would know it's always talking about this row. Well, actually that does work. Some people actually prefer that. In this situation, you wouldn't be using a composite key, you would just be using a single primary key, and it would work just fine. On the downside though, this introduces some problems because now we have to worry about repeating data, for example 7 and 3084. So you might still have to make the combination unique. And if you're going to do that, you might as well just use it as the composite key for that table. But even so, some people still like to be able to refer to a row using only one primary key column, not a combination. So that decision's ultimately up to you. I'm going to try to go with this route using 2 columns, but if I need to, I will just go down to 1 column if I feel like that's relevant for the situation. Also keep in mind, you don't have to limit yourself to just 2 columns, you could have 3 columns. So for example, if the class ID and the student ID is not enough to keep each row unique, you can add a column. You could say semester, because, potentially a student could retake a class. That might not be the perfect example for this situation, but you guys get the point. If you can't make the data unique using only 1 or 2 columns, add enough columns until it is unique. But you always want to get the minimum amount of columns. So if you can use 2 columns to make these unique, why would you add a 3rd column to be part of the key when it's not needed? Always have the smallest key as necessary. Except for the situation which I discussed, we can use 2 keys here instead of 1 just because it makes more sense rather than having this extra column here. When you're looking at your tables, you might have to go through and look at all the different combinations of columns that could make a key, and these are going to be known as candidate keys. Then you have to go through this list of candidate keys and pick which one's going to be the most appropriate for your primary key. Sometimes it's not necessary to actually list all the candidate keys and you can just know, hey, this one's going to work as the primary key. But if you're working in an organization or in school, they might make you list the candidate keys and pick which one would be best for the primary key. Candidate keys also come up when you're talking about database normalization, which is a topic we're going to discuss in upcoming videos. But a lot of the normal forms of normalization talk about candidate keys and not just your individual primary key. You might also be able to guess if you're using natural keys, things can get a little bit more complicated, because you don't just have individual IDs to identify rows. So you might have to combine a bunch of columns to make something unique, which can make normalization a bit more challenging, in my opinion. Let me know what you guys think, if you prefer primary keys as surrogate or natural keys. Thanks for watching. Oh wait, I gotta talk about indexes. When you make a column a primary key, that column is automatically indexed. Now an index allows your database to work with that data much faster. And there's 2 kinds of indexes, or 2 classifications, clustered and non-clustered. Now we'll discuss all the details of this in another video dedicated to indexes, but since this video is about primary keys, I thought it would be relevant to say that primary keys are automatically clustered indexes. And what that means is that the data in the table is actually organized by the primary key. Unique columns, these are actually automatically non-clustered, which that's basically just lists all the data in order but then makes a reference to that data. And as a side note, identity columns, those are not automatically indexed unless obviously it's on a primary key. In that situation it's going to be part of an index. But if you make another column the identity, it's not going to be indexed. Just thought I'd throw that out there if you guys were wondering, which you probably weren't. Okay. So yeah, that's all I got to say about primary keys. Hopefully that was helpful for you guys. If you like this video, please click like. Be sure to subscribe if you want to support this channel. And as always, stay chill. See you guys in the next video. Peace. Welcome back, everyone. Oh, goodness. Hello? Okay. The mic's on. Well, welcome back, everyone, to your SQL Server tutorial series. This video, we are going to discuss foreign keys. Now, I know what you're thinking, and you're wrong. Foreign keys do not unlock locks from different countries. Just get that out of your mind, okay? This is databases here. Foreign keys reference primary keys, or unique columns. And primary keys are also unique, so you can just write unique, and that includes both of them. Why does it have to be unique, though? Essentially, when we want to reference data in another table in a database, we want to be able to say exactly what row we are referencing. So if we have 2 tables, And this row, let's say these lines are rows, and this row wants to reference this row, it needs a way to say exactly what row it wants. And the only way it can do that is if all of these rows are unique. To do this, we need at least one column with the unique constraint. Now, oftentimes, this is going to be the primary key. So I would recommend you watch the previous two videos because these discuss primary keys in depth, and we discussed that primary keys have to be unique. Now, the word unique and also the word not null, these are example of attributes. Now, when I say attributes, I'm not talking about attributes in the sense of entities and attributes. These attributes here are a different type of attribute. So yeah, totally confusing, but just focus on this kind of attribute for right now. An attribute is essentially an extra detail we give the column to tell it how to act. A lot of the attributes are also known as constraints. So unique and not null are attributes, but they're also constraints. Now, we talked about constraints when we talked about data integrity. When we actually use these keywords, they're known as attributes. Now, you can call these constraints if you want, but just know that there are some attributes that are also not constraints. And that gets kind of confusing, so I'm not going to go into a ton of detail with that right now. That's because it's a little bit off topic still. But the reason I bring it up is that we have to consider what kind of constraints we want to put on our foreign keys. So in this situation, this is the primary key, and this is the foreign key. And the foreign key references the primary key. You'll make this association by column. So you might have one column inside of the table, and you say it references this column. That means a value for that column has to match a value for this column. So for example, 7 and 7. These values match. This one over here should always be unique, and we'll probably want to make it not null too. But these constraints are not automatically placed on the foreign key. That means we have to decide, do we want the foreign key to be unique? Do we want it to be not null? That's what we're going to be discussing in this video. Now that we're already like 5 minutes into it. To make the discussion of these constraints easier, it's easy to think in family trees. So a family tree shows how things are related, but you have to introduce the concept of parents and children. When we're talking about databases, the primary key is the parent, foreign key is the child. So rather than drawing things this way, we can flip it this way and put the parent up top and the child down here. So we get something like this. Now you can see that the child references the parent. And theoretically, the parent doesn't have any knowledge of the children. That's because the foreign key is in the child table, not the parent table. So within this parent table, there's nothing that references back to the child. It's alone, it's segregated, it doesn't know of the child. So because of that, I drew the arrows pointing at the parent and not both ways like that. When we draw it this way, it's a lot easier to think about these constraints. First, let's think of the unique constraint. If we use the keyword unique, essentially what that says is that a parent can only have one child from that column. So if we said unique on these children right here, 2 of these would be in violation. Sorry guys. That's because in order to reference the parent, you have to use the parent's primary key. So we'll just say it's a number. Let's say 7. So this child uses 7 to reference the parent. And if we have the unique constraint, that column right here is not going to allow 2 of the same values. So if we try to put 7 here again, that would be not okay. But if we have another parent, this one might have the ID of 8. And this child could reference that parent. And now we're okay. And it might make more sense if, we move the whole thing over there. So let's do that. This is okay. This child still cannot exist because of this unique constraint. Now what you also have to realize with this unique constraint, it's talking about that individual column. We might have another table that references the parent. So imagine it's turning into one of those crazy family trees with stepchildren and all that. Okay, we have a column over here that also references this parent. That means this parent could potentially have another child, but it'd be from a different table. So this unique is only for that column. Now I'm going to erase this a little bit, so get your last image of it. Now, let's discuss not null. We have this previous relationship. We have the parent from this table. One of the rows here has an ID of 7. And then we have a child, let's say right here, and it has the reference 7 in the foreign key column, pointing back to that parent. But now let's create a child over here, and we're not going to make a reference to anything. So that column for this row is going to be null. What that essentially means is that we have an orphaned child. As depressing as that is, you can do that in databases. So when would you want to do something like this? Well, if there's ever a situation where a row does not need to reference anything, but some of them do, then you would do this. It's kind of hard to think of really good examples, but imagine you had a car dealership or something. My car drives fast. And we are leasing the cars, right? You might have a column for leaser, which points back to the customer. Well, if a car is being currently leased, it would have a customer ID, such as 7. But if the car does not have an owner, then that would be null. So in this situation, although it's not the best example in the world, you can see that a null would be appropriate. So sometimes it's okay to have orphaned children. I'm sorry. If you don't like that idea though, and you don't want no orphaned children, you can use the not null constraint or attribute. And essentially that is going to force this child to have some value for the foreign key. So you could not use null, you have to say some value. You would do that if there's a situation when this row over here cannot exist without that parent. Think of like a comments table on a video sharing website. It wouldn't make sense to have a comment without a poster. So you would obviously make the poster column not null. So that's a good summary of attributes for foreign keys and how to design those. In the next video, we are still going to be discussing foreign keys, but we'll be discussing a little bit of a new topic. So thanks guys for watching, and as always, I'll see you in the next one. Thanks guys. Oh, and don't forget to subscribe and click like. What's up everyone? This video we're going to talk about foreign keys, specifically on delete and on update. This is Caleb from Caleb the Video Maker 2. But you guys know that, so let's not waste any time. Let's get started. On delete, why does it always look crooked? On delete is a way we can configure the way our foreign key works. So let's go back to the parent-child relationship concept from the last video. And last video is basically a prerequisite to this video, because I'm going to waste all my time repeating all that information. So we have a parent row and a child row. And this child row obviously references the parent using a foreign key. So this table will have a column such as ID, and then this table will have parent ID, whatever the parent is. So it could be like user ID or whatever. And then that value references the parent. But what happens if we try to delete this parent row? Oh no! And I bet you cannot guess what clause is used to configure that. Yeah, didn't think so, moron. It's on delete. Okay, I'm so mean. Yeah, I'm keeping it in. So on delete can be added after we define our foreign keys, and we can say what happens when we delete the parent. And there's 4 main options in SQL Server: no action, cascade, set null, and set default. We're going to discuss each one of these in a little bit of detail. The first one is no action. That is actually the default. So if you don't say anything, and you just say this is a foreign key that references this column, this is the one that's going to be applied. What that means is if you try to delete a parent, it's just going to throw an error and say, you can't do this, you cannot do this. Essentially what that means is that once a child references a parent, that parent is locked into existence until that child is no longer there. No action is probably the most safe one you can use, because once you start having all these tables and all these references, and this child references this one, and this one references this parent, you got this huge network of connections, and when you have no action, you basically can't break any of those connections accidentally. But this has the downside, and that it makes it really hard to do anything. Because if you have this chain, for example, this row referencing this row referencing this row, you have to find the most childish of all the children. Because if you think about it, this child has a parent, which is this child, which has a parent, which has a parent, this parent. So it's like a literal family tree. You would have to start with this child, delete that row, then you could delete this row, then you could delete this row, and then finally you could delete the parent. So if you want to delete the parent, you're going to have to go through all of that work. Cascade, on the other hand, comes in handy because if you delete the parent, it's automatically going to pass on those changes and just delete anything that references it. But as you can see, that could be very dangerous because you have all these connections and you don't have all the connections memorized in your head. So you just think you're going to do something minor. It's not going to ruin much. You're just going to delete this one row. No one will even notice. Then all of a sudden you delete like 40 rows because everything's interconnected. So Cascade will delete all of the children referencing that parent. Set null, that one is going to set the reference and the child to null. So if this parent has an ID of 7 and in the foreign key column we have that reference, and then we delete this parent, this 7 is going to be replaced with null. That one's fairly simple, but you're going to have to keep in mind that this column that's storing this value has to be able to be set to null. Therefore, it cannot be labeled not null. If it was labeled not null, you wouldn't be able to do that because then you'd try to put a null inside of a not null column. And that's just going to make your database explode. Finally, we have set default. And what that is going to do is set the column to whatever the default value is for that column. When you define the column, you can use the default attribute and give it a value. And then when you delete the parent, that value of like originally it was 7 will be replaced with whatever the default is. So the parent has a value of 7, the child references that parent, and let's say the default is 1. We delete the parent row, the child reference is replaced with 1. Now, when would this be beneficial? Well, a lot of people actually don't like set default, but some people really like it. A good use of this might be, let's say, in a situation where we have a website and people can post comments. So we could make a user in the user table with the ID of 1 and make the username deleted user, for example. And let's say we also have a user, Caleb, and his ID is 7 and deleted user ID is 1. Now the parent exists, his name's Caleb, the child is his comment, and this comment was posted by the person with the ID of 7, which points back to Caleb. But then once we delete the parent, the 7 is defaulted to 1, which points to deleted user. That's kind of a way you could use the set default. I'm sure there's a much more professional and technical explanation of how you could use set default, but that's all my little brain could come up with. So if you guys got some more better examples, post them in the comments below and I'll consider them for future videos and I'm sure they'll be helpful to other people. Now there is also an on update clause. This is going to work the same way because we also have these options. The only difference, it's no longer on delete, but what happens when the parent's ID in the situation 7 is changed? Now, if you used my guidelines on primary keys, they should never change. So the only time you're going to need the on update is if you're referencing a unique column that is not a key. For example, you might have a users table with an ID and a username, and this username is unique. Now let's say we have a username of Crazy Cat Lady 10, and this lady has an ID of 8. That is not an 8. And then let's say we reference this column, which we can do with the foreign key because it's labeled unique. Now instead of having an ID, we'll just have the username. Now the on update is going to make a lot more sense. So what would happen if someone tried to update their username? Well, let's go through the options. The first one, if we had our foreign key set up as no action, the database is just going to throw an error and say, no bro, you cannot do this. Is that appropriate? Well, in some situations, yes, but some websites let you change your username. For example, YouTube. So if we wanted people to be able to change their username, we would not want to use no action. Cascade would send the changes down the line. So if we changed this to Crazy Cat Lady 11, it would go down over here to the reference and change it as well. That would be more like what YouTube is doing. So that means any comment that references this username would change. Set null would change this username to null. And finally, set default would change it to whatever the default username is. So whatever this table is in, we would have a column, let's say username, and this could be in whatever table, it doesn't matter, and you would give it a default. So hopefully that kind of gives you a good summary of on delete and on update. It kind of gets complex, but if you just break it down piece by piece, you'll eventually get it. So thanks guys. If you like this video, please click like, subscribe, and send me some money to replace my lungs from all this chalk dust. Kidding, but I mean, still send me money. Gosh. Okay. Thanks guys, I'll see you in the next one. Peace. Hey, what is up everyone? It's Caleb from Caleb the Video Maker 2, and welcome back to your SQL Server tutorial series. This video, we are going to prefix the next 3 or so videos. That's because the next 3 videos go into a new topic, and I don't know where to piece all this information in, and I don't really want to bombard you with a ton of information in those videos. So I thought it was necessary to pull out some information and just kind of make a foundation for the next few videos. So this video, we are going to introduce the topic of database normalization. Anytime you study databases, you will come across the term normalization. Guarantee it. It's basically this process that is used to improve the database structure. Think of like this X-ray that like scans your database and is like wrong, 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 and points out all the bad things and helps you fix it. Now obviously this isn't automated, although that'd be pretty cool. It's something we do. So we look at our database with our normalization glasses and scan for different rules. And when we find one of these rules that are broken, we fix it. It's a pretty simple concept, but it's kind of complex and complicated, so I'm going to try and keep it as simple as possible. That's because whenever you study this stuff online and you look up a definition, they'll give you like 40 different terms that you've probably never heard of, and even I am like, what? So that being said, this is going to be a pretty simple introduction to database normalization. Then maybe later down the road we can go into a little bit more detail with all of the functional dependencies and fancy terms and all that kind of stuff. But I will try to give you as many terms as possible. So don't think this is going to be like baby level. This will be like entry to mid level. Alright, so let's do this. As everything is in databases, normalization is broken up into sections. Basically, we have these steps we take. So we scan our database, and we find everything that's wrong with it. And then we're like, awesome, we got past stage 1. And then we do it again. And we find even more errors. And we do this as many times as we want until we get through all of the different normal forms. Normal forms, by the way, are what the steps are called. How many normal forms are there, though? Well, there is actually a lot of normal forms, but we, as beginner noobs, we are going to focus on first normal form, second normal form, and third normal form. And these are abbreviated as 1NF, 2NF, and 3NF. Consider these our X-ray goggles that scan our database, and each level is progressively more strict. So the first one might scan it and say, oh yeah, here's a couple things wrong, but it's, it's not a huge deal. We'll just get rid of those. But then the second one, it also has to pass all of the first normal form rules too, and additional rules. So this one is like, oh no, there's a lot of more errors, we gotta get rid of those. And by the time you get to third normal form, you have to have both first normal form, second normal form done, and then we scan our database, and we get more things wrong with our database than things right with our database. When we study this stuff, the concept of dependencies will come up. Now, what is a dependency? Essentially, a dependency is when a thing, oh, this is totally not helpful, but a thing depends on something else. And the simplest way I can explain that is using the idea of entities and attributes. And this goes back to way the beginning of the series. So if you don't know that, make sure you start from the beginning of the series. But essentially, an entity is anything we want to store data about, and an attribute is the data we store about the entity. So we kind of get this little diagram. So each one of these would be something describing this entity. You could, however, word it that the attribute depends on the entity, and this would be a dependency. Now, there are numerous kinds of dependencies. Some are appropriate and some are not, but we will go over a couple. But just so you know, when you study normalization, they're going to talk about all kinds of different dependencies. And when you hear that term, I want you to think of an attribute describing an entity, or essentially a column inside of a table. So if we have a users table, one column might be the username. I always make it way too small. Let's try this again. Boom. Okay, there we go. Now this username depends on the user. That's because if we changed the username would also change. So to think about that, we can draw some users. Still am bad at drawing. Here's a user, and here's a user. And each one of these users might have a username. So the value of username changes based on the user that we're talking about. That is an example of a dependency. Now going beyond third normal form, there's Boyce Codd normal form, fourth normal form, fifth normal form, blah 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 normal form, and yada yada normal form, and just a bunch of other things. But once you get to third normal form, you can basically consider your database to be normalized. Normalized is a state where all of the normal forms have been done on our database and we fix all of the problems. This is obviously something that is subjective. That's because some people would consider third normal form to be normalized, or other people think you have to go farther down. And it really just depends on the application. I personally think third normal form is suitable for 99% of applications, so there's really not a huge reason to go past that, but occasionally there is, so it still might benefit you learning the other normal forms. Now, all of this is designed to help us get data integrity. And I know we've had like a crap ton of videos over data integrity, and you're probably sick of hearing that term, but as I said, it's very, very important in our database. If you go through the normal forms, you can basically assure yourself that your data has integrity. How exactly does this help our data integrity? It helps it by preventing anomalies. An anomaly is something out of the ordinary. There are different types of anomalies, such as insert anomalies and update anomalies and delete anomalies, but if you had to summarize it all, essentially, when you do something with your database, it does something that is not expected. And that stems from our data not having proper integrity. So if we can get rid of anomalies, then we can protect our data. How do we get rid of anomalies? By reducing redundancy. What is redundancy? Redundancy is when we have the same information in our database 2 times or more. You can think of if we had a user table, and let's say we have username, name, and phone. And when we insert data into this, we give a username, we give it a name, and a phone number. And now let's say we want to add a second phone number. Well, let's just add another row. And in this situation, we have data redundancy. That's because we have this username in here twice, and we have this name in here twice. Now, if these were foreign keys and they pointed back to one entity, that would be okay. But in this situation, it's not okay because we have the same data repeating. And if we were to try to update this data, let's say Caleb got a name change, well, now we go and say, oh, let's grab this row and update it to something else. So instead of Caleb, we're going to have John here. This is a perfect example of an anomaly. That's because now we have John and Caleb in here, and they're both the same person. So is this guy's name Caleb or John? I don't know. And there's no real good way to find out. So we do not want anomalies ever. When you study normalization, you're going to come across different terms such as candidate key. And there are a few others. Essentially what a candidate key is a combination of columns, or just a column, that can uniquely identify a row. So basically we're going to have numerous candidate keys, and then we have to pick which one is going to be the best primary key. So let's say this one's the best. We could say, oh, this is our new primary key. When you go through these normal forms, it's going to be talking about all of the candidate keys. Now, candidate keys come in more commonly when we're using natural keys, which have real-world meaning. That's because we have to find a good combination of columns to force something to be unique. But when we're using surrogate keys, we almost always just have an ID column. And if that's the situation, we only have one primary key. And because of that, I almost ignore the candidate key. Now, it's probably not like the world's best practice, but, you know, it works. As long as we have a primary key that's unique, not null, and never changing, I don't see a huge reason in freaking out about all of the different candidate keys and all of that stuff. That means in the upcoming videos, I'm going to be talking about first normal form, second normal form, and third normal form relating to the primary key. I think that's an appropriate way to start database normalization, especially when we're using surrogate keys which have IDs. Let me know what you guys think. Do you think it's a huge deal to focus on all of the candidate keys? I guess it might be more helpful to go through the videos over the normal forms and then come back and let me know what you think. But people have different attitudes and different thoughts on all of this information. So hopefully all of that information was a good foundation for the next 3 or 4 videos. That way when you go in there, you're not going to be completely lost and I'm not going to have to do a 12-minute intro to first normal form. If you guys like this video, give me a comment and let me know you liked it. Be sure to click like, and as always, be sure to support this channel by clicking subscribe. That helps me out and it helps you out because now you'll get all of my new videos in your subscription feed. That is all, guys, so I will see you in the next video. Hey everyone, welcome back. It's Caleb from Caleb the Video Maker 2. This video we are going to be discussing first normal form of database normalization. If you're completely new to normalization, be sure to check out the previous video because that's where I give the foundation. Now to put first normal form into very basic, simple English, all we have to do is put our data in tables and don't design the tables like a noob. That's it. So we want to follow the rule of 1, also known as atomicity. When you start thinking about what kind of data do we want to store inside of a database, you start to separate things into entities and attributes. Even if you don't do this on paper, I know you do it in your mind. You just might not think about it. Entities are things we store data about. Here are a bunch of examples of entities we could have. And attributes are anything we want to store about them. So for example, on the orders, we could say who bought it, what they bought, where they bought it, when did they buy it, why isn't really relevant in this situation, or how. But yeah, how could be like credit card, cash, all that stuff. So that is kind of how you separate data. Entities go into tables. Each one of these is going to be their own table. Attributes become columns. So for a specific order, inside of that table, we're going to have all of the columns I mentioned. Who bought it, what they bought, that might need to be separated a little bit, but who bought it, what they bought, where they bought it, if there's a store location, the date and time of when they bought it, all of that information becomes a column. But it's important that each attribute is one column, and one column describes only one attribute. This here is essentially how we describe atomicity. Every column is indivisible. So that's what atomicity is. I mean, imagine like atoms, you know, those things they try to teach you about in science classes. At one point, we thought we couldn't split them. So we come up with the great idea of saying, this is all atomic. So that is how that term came to be. So let's kind of go into an orders table and kind of expand it and look at some data that might be inside of that table. Inside of the orders table, we could have an order ID, and this column is super important when it comes to first normal form. Just like how one thing is described by one column, well, each row needs to point to one individual instance or one individual order. So each row inside of this table is going to be an example of an order, one instance of an order. The way we distinguish orders is using an ID or some kind of primary key. So for first normal form, we need to make sure things are atomic and everything has a primary key. That means every table needs to have a primary key column. In this situation, we're using what's known as a surrogate key, and that's just an ID. It has no real-world meaning, it's just for the database's sake. We might also have a customer. Now this is a column that stores one thing, so we would have one customer. So let's say we have a website where you can buy stuff, someone places an order, it might be order of 1012, with the customer ID of 782. All we are doing is storing one customer. If we look at the value for an individual row, we are storing one customer. These seem kind of like the same thing, but for the column, we could have named it customer, comma, email address. And that just seems so not normal. Like when you try to design tables, I personally don't find it intuitive to break first normal form. It's intuitive to follow first normal form. That's why I said don't design tables like a noob. if you have a column, don't try to store a customer ID and an email, because that's two separate things. Obviously, each one's going to need to be put into their own column. Additionally, we don't have customers as the column title. Customers is plural, and that would imply that you could put multiple customer IDs in one row, such as 783 being somebody else. You don't want to do that. So we want to make sure the column header stores one thing, customer, and it only stores one of them. Additionally, an individual row talks about one thing. In this case, one specific order. So if we needed to add another order, we would have to add another row. And if for some reason we had to have two customers for one order, we would add another row. Now, in this situation, you can see there's a problem. That's because we have a repeating primary key, which is not okay. So in this situation, you have to break things off into a new table. We'll worry about that in just a moment. That's because I'm just trying to show you guys what it means to follow the rule of one. Everything describes one thing. A table is only talking about orders. Every row talks about one individual order, and every column header talks about one attribute for that order, and every value for that column stores one individual value for that attribute. It's a lot of stuff, but essentially all you got to think of is do everything singularly. You never want to store a set inside of one of these. A set would be like a group of things. So if you're storing a comma something else or a semicolon something else, you're probably breaking first normal form. Now this is just kind of like a rough example. Let's go over a more specific example that's going to require a little bit more explanation. In some of my other videos, I started to talk about this database we're going to work on. And this database is going to be a database for an animal dating website. So your little animals can go on to this website and find their love. These actually exist, by the way, just so you know. So in our situation, an animal goes on this website and creates an account. So that would be stored inside of a users table, essentially. We'll call it animals so it's a little bit more clear that this is for an animal dating site. We'll add a couple of different columns in here so you can see what data would look like. So here's our table. We'll have the animal's name, the species of that animal, the color of the animal, and the type of species the animal is interested in. Let's add some data to this. Sally is a bunny, color is brown, interested in, let's go with bunnies, just to keep this nice and simple. Now the column I'm going to be focusing on in this example is this one right here. So if we wanted to follow first normal form, we need to make sure that the column header is only storing one thing, interested in, which in this case it is, so we're following that. If we weren't, we could have it interested in, comma, not interested in this. And in that situation, we'd be storing two different types of attributes in one column, and that would be a no-no. You don't want to do that. We're already good with that. We're not trying to store two things in here at once. That being said, we also don't want to design this to expect a set of species that this animal is interested in. So, interested in bunny, semicolon, gerbil. In this situation, we are breaking the rule of one because we're storing two values in an individual field, which is not okay. So how do you notice this early? Well, just be aware if you are doing something like interests, plural, you might be designing your database in the wrong way because you're setting it up to expect a set, meaning multiple values. Interests is plural, so you would expect multiple values for it. So how do we fix this? Well, to start off, let's just add a row. So Sally is interested in bunnies and gerbils. So let's just add a row for another Sally, and then we can get rid of this old one. So this fixes our problem of having two values for a column. Let's put that back to interested in. But now we have the problem that two rows describe the same bunny. Gosh, I stink at drawing. This here is also very bad, and you don't want to do this in database design. That's because in this situation, it doesn't follow the rule of one. Now, in some tables, it's okay to have repeating data. For example, if we have a comments table, a user could post 400 comments. That user is going to be inside of that table numerous times. But the table itself is describing comments. So each row would want to describe an individual comment, and we wouldn't want to have two rows describing the same comment. So this always points back to what the table's about. So in this situation, we have two rows describing one animal. That's not okay. To fix this problem now, we actually need another table. So I'm gonna draw some room. That doesn't even make sense. We will name this table interests. Now it's okay to make it plural in this situation because we're going to be storing multiple rows, so there's going to be multiple interests. But always remember, each row is only one interest. Now we're going to have to be able to refer to a specific animal. And in this situation, there's not a really good way to do it, unless we made the name unique or something, but that's not the best way to do it. That means we need to introduce a primary key. So I'm going to erase this over here and add a primary key column. And we'll put an X there because we know that's not allowed. The primary key is a way we force that every row talk about only one entity. That's because we can't put another one in here because it'd have a different ID. For example, if it said 2, it would be a different animal. So let's put that back to an X. So always make a primary key in your tables. Now, inside of this interest table, we can reference that specific animal. So first we could say the animal ID. Then the other column could be this one here. Now the animal ID would be 1. The interest would be bunny. Then we could repeat that animal ID, 1. And it's okay to repeat it here. That's because this animal ID is not talking about the interest, it's talking about the animal. These here are two separate interests. They just both happen to be from the same animal. So that part's kind of confusing, but just think we can't have repeating interest because that's what the table is about. These interests are going to be distinct because each one is going to have a different animal. So in this one it'd be gerbil. And you can see that the combination is unique. That's because these, as a group, do not repeat. One bunny and one gerbil are different. So we're not breaking the rule of 1 here. Now back in our original table, we're not even going to need this column. And we don't even need to have any way to reference this table. That's because we're essentially designing a one-to-many relationship. And if you go back to our one-to-many video, you'll know that this is the parent table and this is the child table. And when we have that situation, the child is going to have a foreign key pointing to the ID, and the parent table is not going to need to know about the child. Now what about this row? Obviously we're not even going to need that row, so we can just get rid of it. So if we had to clean this up, which I guess I will, get rid of this column and get rid of this row. And the last thing when you're working on first normal form, make sure each column is actually about whatever you're trying to describe. These all depend on the primary key. But you wouldn't want something in here like the weather. Okay, the weather has nothing to do with the animal. So in this situation, this is not dependent on the key, and we always want every single column to depend upon the key. Now, all of that was a lot of information. So don't get overwhelmed. All you have to remember is to follow the rule of 1. When you're designing a table, just do it intuitively. Make things as singular as possible, make each row describe an individual entity, and in the end, you'll be good. Don't worry about it. Because once you get to second normal form and third normal form, that's going to take your crappy database and slaughter it. And then you're going to have something a little bit better. Thanks guys. If you like this video, please give it a like, and I will see you in the next video. Oh, and don't forget to subscribe. Please. Holy crap, that was a long one. Hey everyone, I just ate some cookies. Yummy. Welcome, my name's Caleb from Caleb the Video Maker 2. This video we're going to be discussing second normal form. Second normal form, oh dang it. Sorry, where was I? Okay. Second normal form. It's the second in the normalization process, as you probably would have guessed. Now, the prerequisites of second normal form is that you've already completed first normal form. So make sure you watch the previous video. That's going to tell you how to get to this point. Now, second normal form deals with something known as partial dependencies. Now, we've talked about when you have a value for a column, it depends on that entity. Partial dependencies come in when you have 2 or more columns for the primary key. So this always deals with compound or composite keys. When you have multiple columns that are part of the primary key, that primary key is known as a composite primary key. So let's say we have one key over here and one key over here. Now, this is where the partial dependency comes in. When you have a column, it depends on that primary key. So that means if we have a column down here, it's going to need to depend on the primary key. But when we have composite keys, it has to depend on both of them. But if we have a partial dependency, it depends on less than all of them. So for example, if we have 3 columns that consist of the primary key, it has to depend on all of them. If it only depends on 2, we have what's known as a partial dependency. So in the situation of only having 2, if it depends on only 1, we have a partial dependency. Now I know this is all conceptual, but give me a couple minutes, I'll give you some examples. But for now, just know that partial dependencies are bad. The entire goal of second normal form is to get rid of partial dependencies. And what that means is if you don't have a composite key, you don't even have to worry about second normal form. That being said, some of the principles inside of second normal form can still be applied and can help improve your database. The reason that is you actually never have to use a composite key. You can force yourself to always use a single column for a key. For example, if this is named column 1, it's a really awesome name, and this one's column 2, instead of having a composite key, in theory you could just have column 1, column 2 ID, and then just give it a number. And then this would not be a composite key because it's just one column. That being said, the data in this table should still depend on both of these because that's how the table is set up. You're just gaming the system by adding a new column. It doesn't improve your database any, it just makes it worse. So only add a column if you already know how to design the database, and don't just add a column to avoid second normal form, because that's going to defeat the whole purpose. Second normal form is a good thing, not a bad thing. So if you see yourself trying to kind of squeak through the cracks and avoid having to do the rules of the normal forms, then the chances are you're adding a layer of complexity, and that complexity is layered on top of a bad designed database. So don't be obnoxious. Don't try to game the system. Follow the normal forms and everything will work out just great. Now that we talked about the concepts, let's go over some real examples. Really practical examples. Back to our animal dating site. I ate that cookie and now my throat's all like... But first, I wanted to explain one more thing. Second normal form comes up more often when you have natural keys. The reason that is because when you have natural keys, you often have to think of more columns in order to force things to be unique. Not always, but in general, you can just add an ID to whatever table you have, and you're good to go. Which is kind of funny because I was kind of just yelling at you guys not to do that just a minute ago. But essentially, that's what surrogate keys do. Oh, I'm such a hypocrite. Essentially, if you're using single column surrogate key columns, that's good. But there are circumstances when you're going to have multiple ID columns inside of a primary key. For example, when we design a many-to-many relationship in databases, we break that up into 2 one-to-many relationships. So to do that, we need what's known as an intermediary table or a junction table or a... I got nothing else. And when you do that, you're going to have 2 columns in there. At least, it depends on how many tables you're joining. And the group is going to have to be unique, not just one column. In that situation, you have 2 IDs and you're still using surrogate keys. The primary key is the combination of the 2 columns. In that situation, you are required to understand second normal form. What I am advising against is adding a 3rd column to, say, the combination of both of those IDs. So I guess there's a fine line between making it easier on yourself by using IDs and making it harder on yourself by adding too many IDs. And that's a fine line that you're going to have to find because it's a little bit subjective depending on you, the database management system, and also the project you're working on and the team you're working on. Some people like to have that 3rd column just so you can reference an entire row by one ID rather than a group, but some people prefer not to, just so you don't have that extra column for no reason if they don't need it. Now, moving on to super practical examples. We are starting an animal dating site, and we need a way to express relationships between one animal and another animal. I personally think one of the easiest way to design databases is to start with the wrong way to store data and then start picking away all of the obvious things that are wrong, and you end up with something a little bit prettier. That's kind of how the normal forms work, so we'll start with a bad designed database, go through the normalization process up to second normal form, and then we'll be good. In that situation, we still might need some improvement, but that's what third normal form is about, which we will discuss in the next video. But for now, let's start with the animals table. Now, I'm not going to spend a whole bunch of time writing out all of the columns. That's because there's only one column I'm really interested in, and that is the column of who the animal is in a relationship with, whether it be dating or marriage or betrothal or whatever. So there might be a column in here such as relationship with. So we'll have an animal ID, because we always need some kind of primary key, and then we'll have relationship, and let's put some data in here. Let's say there's one animal with the ID of 3, and an animal with the ID of 4, 5, 6, and 7. So these are all different animals. And now this is actually a foreign key. But how does this work? It's actually a foreign key that references the same table. It just references a different column. So this relationship with column references the animal ID column. I don't know where I was going with that. So we could say the animal with the ID of 3 is in a relationship with the ID of 4. But that means that the animal with the ID also has to be in a relationship with the animal of 3. Because you have to update 2 rows every single time you want to store one relationship, this isn't the best way to design it. This can introduce anomalies. For example, 3 could be in a relationship with 4, and 4 in a relationship with 5. And now it's this chain, and that's not the way I envisioned this dating website to work. So because there's an association here, you can see 3 is associated with 4, and 4 should also be associated with 3. This would be a good example of when we should use an association table, or a table inside of a many-to-many relationship, an intermediary table. The odd part of this, though, is that there's only going to be a total of 2 tables rather than 3. So imagine it like this. We have a table for animals, and then we have the intermediary table, and then we have a third table, which is also animals. Now obviously these are the same exact table, so we don't need to draw it twice, but that's essentially what we're going to do when we're thinking about this, but when we actually design it, we'll only use 2. So we could say we have an animal over here with the ID of, let's go with 3, and an animal ID over here with 4, and we combine them of 3, 4 inside of our table. But since we're only using one table and this references the same table, we only need 2. So let's draw a table, and this will be named relationships. We actually haven't really talked about second normal form in this example yet. This is kind of just to prepare us for a situation where we might run into second normal form. So inside of this relationships table, we can make an association between 2 animals. So we would have animal 1 ID, animal 2 ID. And now we only have to put in 1 row for every relationship. So we could say the animal with the ID of 3 is in a relationship with the ID of 4, the animal with the ID of 4. And now we don't have to go and put 4, 3. That's because that association is already made. So that means we have to assume that this is a back and forth relationship. So 3 is in a relationship with 4, and 4 is in a relationship with 3. If you wanted to make it to where 3 could be in a relationship with 4, but 4 doesn't have to be in a relationship with 3, if you wanted to do that for some reason, then you would need to think of actually adding rows for each direction. So we could say 4 is in a relationship with 5. But as I said, that's stupid. I don't want to do that, so we're not doing that. Because we have this association now, we're not going to need this column. And now this table would just have data on the animal. So we'd still have the animal ID, the animal name, the animal species, all of that stuff. This table is devoted to just the relationship. If we wanted to add a different relationship, we would have to use different data. That's because this dating website is not going to allow one animal to be in a relationship with multiple animals, because that's just messed up. I'm gonna teach these animals purity. Okay, so that means 5 could be in a relationship with 7, but we can't use 3 again in this column. What that means is that this column can be unique and this column can be unique. You could also make the group as a whole unique. That way we don't have any repeating data. Now, something I don't know is how to enforce uniqueness this way. So that way, if we had 4, 3, it would be a violation. So if you guys know how to do that, please leave a comment and let me know how to do that. But for now, we'll just leave it at this. So that way we can have 3, 4, but we couldn't have 3, 5. You sick animals, gosh. And you're probably wondering, where in the world does second normal form come in with all of this crap? Well, it comes in with this. That's because we have a combination of IDs as the primary key. And when we have that, we have a composite or compound key, and there's a potential for partial dependencies. So where does a partial dependency come in? A partial dependency in this situation would be any data describing the animal. For example, if we had a column here, running out of room, so it's going to be a really small column. And if there were any attributes describing one of the animals. So let's say we had animal 1 species. That's really good information to have in the database. The only thing is it doesn't belong in this table. That's because the A1 species is dependent only on animal 1. That's because it's only describing 1/2 of this table, the first animal. So if we had a normal many-to-many relationship, let's say it looks something like this. Beautiful, I know. And inside of this table, we had information related to this entity. That would be a no-no. The only information to go inside of this table has to be relevant to both of the primary keys. The way you can tell if it depends on both keys is if you change one of them, is the data able to change? For example, in this situation, we have A1 species. If we changed animal 2, let's just say we change this to an 8, right? Well, this data is always going to be the same. That's because there's no connection to animal 2 at all. So if you have another many-to-many relationship, just ask yourself, if we change this half of the table, is this attribute going to change whatever attribute it is? If there's a column in that table and you change one of the primary keys, is it able to change? In this situation, if we change this column is unable to change. Therefore, we have a partial dependency. That's because it only depends on part of the primary key. Now, you might be asking yourself, if we can't store this here, what kind of information could we store in a table with a composite primary key? Any kind of data that describes the connection of the two entities. So let's say we have these 2 rabbits and they are in a relationship, right? Well, any data that describes this relationship could be stored in that intermediary table. For example, we could have a column establishment date. That would be the time or date of when this relationship started. We could also say type of relationship. For example, we could have, dating, married, engaged. It's complicated, and so forth. This data all describes the relationship. So this would not be in violation of second normal form. Hopefully that describes second normal form pretty well. Just be careful of those intermediary tables because that's where it'll sneak in on you. Thanks guys, hopefully it was helpful. If you like this video, click like, and as always, click subscribe on my channel because that really helps me out and encourages me to make more videos. So thanks guys, in the next video we will be talking about third normal form. Thank you. I know I've said that like 4 times, but I'm really thankful. Do you guys like my drawing? It's better than usual, so I thought I'd ask. Welcome back everyone to Caleb the Video Maker 2. Wait, that's like 4. 2. Every stinking time I make a video, my dog drinks. Welcome back to Caleb the Video Maker 2. This video we are going to be covering the third normal form of database normalization. Now, the first rule of third normal form is that it's already in second normal form. So go make sure you watch the previous video and also the video before that. Before we dive into third normal form, let's refresh our memories on the term dependency. This is when something depends on something else. The example I gave to describe a dependency is when you have an entity and an attribute describing that entity. You can say that this attribute is dependent on the entity. So this entity will have a primary key, let's just say it's an ID, and then an attribute of, I don't know, name. You'll often see these dependencies drawn with an arrow like this, meaning that when you change the ID, the name will change as well, because it's a different person or a different whatever. So 7, Caleb. 8 might change it to something else. That's because we're talking about a different entity. So essentially, all we're saying is that all of the columns inside of a table depend on the primary key of that row, or whatever the table is about. So if we have a users table, you can say that all of the columns depend on the user, and we'll often describe the user using the primary key. So we would say all of the columns are dependent on the user ID. That kind of dependency is okay. There's other kind of dependencies that are not okay. For example, in the last video we talked about partial dependencies. Well, in this video we are going to discuss a type of dependency known as a transitive dependency. A transitive dependency is when something depends on something which depends on the primary key. So you get this bouncing kind of arrow thing. So I know that made no sense at all. So the easiest way to explain this is just to go through an example. We are going to continue to use the example of our animal dating site. And going back to first normal form, we set up a small database where we had animals, or basically user accounts on this website, and then we also had interests. So a animal could sign up and then say the different types of animals that they're interested in. So the structure was something like this. We had the animals table, and then we had an interests table. One of the columns in here was an animal ID. The other column was an individual interest. So the columns might be ID, name, species. And then let's give some data for this. So we'll have an animal with the ID of 16, named Sally, and the species will be bunny. And this bunny has interest in other animals. So we add a row to this interest table referencing that ID. So it'd say 16, and this thing is interested in bunnies. And then also 16 and gerbil. So this is our table structure so far, and there's really not anything wrong with this table structure. So where does third normal form come in? Well, if we were to add columns to this interests table, you might run into some transitive dependencies. For example, here we have a species name, but it's really just a friendly species name, because you know, if you looked up different species specifically, they're going to have these long scientific names that describe them. So let's say we want to store the actual species and the friendly name. So we're going to alter this table a little bit, and we'll say interest species, then we'll say the friendly name. So we can move these friendly names over here to this column. Then in here we can put some crazy scientific names. Orictologus cuniculus. Oh, my biology teacher would be so proud. Murionus ungulacatus. And there we go. Now we can know exactly the species that this animal is interested in. Because you know, you say bunny, that's very vague. There's like 4 trillion bunnies. So if we say Orictologus cuniculus, then we know exactly what the bunny's interested in. This is where we introduced a problem though. That's because there's a transitive dependency in this table. This friendly name actually depends on the interest, and the interest depends on the animal ID. So you can see there's like 2 dependencies in a row. And by this, the friendly name still depends on the animal ID. Think back to math class when they say something like, A is less than B, which is less than C, therefore A is less than C. That's kind of how it works. So this friendly name is dependent on the animal ID, but it's dependent through another column. So you can see the way we have our database set up is just messy. How do we go about fixing this? What you need to do is take the column that this column depends on, in this case interest species, and break that off into its own table. And specifically, we could just take the species because that would be more useful. Because why limit the table to species that animals are interested in when we could just make a table for species? So we need to do that over here. So we'll say species, and inside of here we'll have a species ID, and we'll store just the genus and the species. So we'll say genus species, which that's what that is. This is the genus and that's the species. And then we'll say friendly name. Now we can add this as a row in this table. Now in here we can replace this with a reference to the species. So we can get rid of this column and this column for now. And now we'll have a column species which references the species this animal is interested in. So we would just say 1 and 2. And if by chance we were to add more rows to this, all we would do is just add whatever species we... Onyx, would you be quiet? Gosh! So we can say 7... Oh, noob! I love you, but be quiet. So we could say 17, 2. You can see that this fixed our transitive dependency because we're not having any data about the species in this interests table. And you can see up here, this might be an issue. That's because if you have like quadrillion species in here, this might be very redundant because it's a very vague name. So you might want to break that off into like a friendly name table or something along the lines of that. In addition to fixing this problem, we have the added benefit of improving this table. That's because this species column can be replaced with a reference to one of these rows. So this is a bunny, so we could replace species with 1. And now this just points to this row right here. And there you go, guys. That is third normal form. Hopefully that was nice and helpful and you enjoyed that. So if you did, be sure to click like, and as always, subscribe to this channel because that really helps me out. Thanks, and I'll see you in the next video. Welcome back, everyone. It's Caleb from Caleb the Video Maker 2. This video, we are going to continue our discussion of normalization. Now, we've discussed the 3 normal forms, so I'm not going to go back and explain all of that information again. That's what the previous videos are for. The point of this video is to kind of summarize it so you can look at the big picture. Now, I'm sure you know that the big picture is to help our data be correct, or essentially to improve the integrity of our data. But still, I think there's a couple things I can add to help you understand why we do normalization and why it's important. If you had to summarize normalization and say what these 3 normal forms do, you could say it helps us better describe an entity. It helps us make sure our data is describing what we want to describe. That means that all of these relate to the key in some way. So the first normal form, the purpose is to make sure everything's atomic for one, but ultimately we want to make sure that the attributes describing the entity are appropriate for that table. So we want to make sure that everything in that table describes the key in the smallest way possible, meaning columns are singular and each row only stores 1 value for that column. So for first normal form, we need to make sure that all of our columns depend on the key. So a key is just a way to describe the entity. So we say user ID would be the way we talk about a specific user. Because think about it, we have to pick an attribute that allows us to talk about an individual thing. We could use a picture, we could use something else. We decided to use an ID. This is the primary key. And all of the columns in this table need to depend on the primary key. And each attribute needs to have its own column. Now with second normal form, things get a little bit more complicated because we no longer just have this simple dependency. We have what's known as a partial dependency. Essentially what second normal form says is that every column needs to depend on the entire key if we have multiple columns. So this is most common in many-to-many relationships. That's because we'll often have a combination of columns here as the primary key, which means any data in this table needs to depend on both. If it doesn't depend on both, it's what's known as a partial dependency. So second normal form, everything describes the entire key. Now when we go into the grounds of third normal form, we're talking about columns that do depend on the key, but they depend on the key transitively, meaning through another column. So if we have a table and we have 3 columns, for example, you have to have at least 3. This column might depend on this one, which depends on this one. So you could say this column depends on this one through this one. This is a transitive dependency. So in this situation, this column right here depends on the key transitively here, but it also depends on this column too. So in this situation, there's two dependencies. It might be a little easier to think about this if we switch these columns. So let's say this one depends on this one, which depends on this one. So if we had to label these A, B, C, we would say C depends on B and A. So third normal form gets rid of these transitive dependencies. Another way to word that though is to say that every column depends only on the primary key. So in this situation, C doesn't only depend on A. That's because it depends on the key and another column. So third normal form makes sure that every column describes only the key. So to summarize, first normal form, every column has to describe the key, singularly. Second normal form, every column describes the entire key, and third normal form, everything describes only the key. Or some people say nothing but the key. So they'll say the key, the whole key, and nothing but the key. So that's a pretty good summary of all the three normal forms. Hopefully that was helpful. If you guys want to learn more about normal forms, I do have a database design series where I discuss some more examples. And also you can research online Boyce-Codd normal form and some of the other normal forms. We might get into some of those later, but for now I think this is adequate for what we are trying to accomplish. Let me know what you guys think. Be sure to click like and leave a comment. And as always, be sure to subscribe to this channel because that really helps me out. Thanks guys, and I'll see you in the next one. What is up everyone? It is Caleb from Caleb Video Maker 2. This video is going to introduce you to the concept of queries. So we're going to run a couple of queries in SQL Server. Now, we haven't really done a whole lot of on-screen content, so we're going to start kind of slow. But be patient because we are going to speed up as we go, so I'm not going to bore you for the rest of this entire series if you are not a complete beginner. Now, I did want to mention to you guys, this is video number 23, and I decided starting with video number 23, I am going to do a competition between SQL Server, MySQL, and Oracle. You know, just to see which series you guys like the most. So if you like SQL Server, be sure to click like and view all of the rest of the series because I'm going to add up all those points and see which one gets the most points. And the winner is going to get 50 extra videos for the series. So I ain't going to waste your time anymore because it's already been like a minute. So let's connect to our database. Now, when you first connect, all this crap's over here. We're not going to worry about that right now. What we want to do is click New Query. This is where we put all of the commands that we want to tell the database. For example, we can create a database using the create command followed by database, and then we can give it a name. And then to execute that, we just press F5. Now we can go over here and look at our databases, and boom, look at that. We got a subscribe database. But the focus of this video is not creating databases. I actually want to talk to you about expressions. An expression is essentially anything that can be evaluated by SQL Server. What do I mean by evaluated? Well, remember back to math class, you'd have, these problems and they'd be super hard, like 5 plus 5, and you had to evaluate those to an answer. So you could say 5 plus 5 is an expression. So we can have SQL Server evaluate expressions for us. The way we do that is use the select keyword, and then we give it an expression. 5 plus 5. Now, the semicolon at the end of these is actually optional, although I am going to try to use it because it's recommended, and if you have two select statements in here, for example, select 5 plus 6, you can run both of those at the same time. This is known as a delimiter, and it tells SQL Server that there's going to be another command after this one. But if there is not a command after this one, for example, let's just say we had this, you do not need it. You can put it, so this would work, but it's optional. If you have two statements and you want to run them both at the same time, it is required. So essentially, the last semicolon is optional, but as good practice, you should probably put it in there. All right, but I'm getting off topic. Let's go back to queries. All right, so let's run both of these. So press F5, and you can see the first one returns 10, and the second one returns 11. And you can see here I actually did not put a space after the 5 here. That's because SQL is not white space sensitive. So what is white space? White space includes spaces, it includes tabs, and new lines. So you can see I just put a space, tab, and a new line, and when I run this thing, it's going to work just the way that it did before. Now there are some limitations to this. For example, we can't put white space between a keyword. For example, when we do that, it's no longer a keyword. Additionally, when we are working with string data, for example, if we have that, if we put a space here, that's actually a different string. And I'll show you that, because we can actually put a string inside of a select to return it to us. So this here can actually be returned back to us. So we can tell the database, hey, we want you to give us this string back. So to do that, all we have to do is say select followed by that string. So this is a string, and a string is just a collection of characters. Each one of these is a character, and it's surrounded by single quotes. So let's run this, and you can see it returns that string. Now what I was saying about white space is that when we delete this white space here and then run it again, you can see that it returns the same thing that's put here. So the white space inside of these quotes makes a difference, but the white space here makes no difference. You can see that the result is exactly the same. One other thing that I wanted to mention in this video is comments. A comment is something we can put there for our use, but SQL Server just ignores it when it runs the query. To put a comment, you put 2 minus signs, and then you can put whatever you want. So you can see here, this is a different color, and SQL Server is actually going to ignore it. So if I execute this, you can see makes no difference. Now these 2 minus signs, this is an example of a single line comment. What that means is when we go down to the next line, we are no longer in a comment anymore. And you can tell because it's a different color. So down on this line, we can put other commands. And I'm just going to add that semicolon there to get into my good practice. The other type of comment, though, is a multi-line comment. And the way you do that is a / asterisk / and then in between these two asterisks, that's hard to say, you can put whatever you want. And now you can see this entire section is ignored by SQL Server. Now you don't have to put these on multiple lines. For example, this is all on one line, but it still works as a comment. So yeah, that's a pretty good rough introduction to queries. Now, we never dived into all of the keywords and everything you can do. That's just because there's too much to cover in one video. I'm already feeling a bit scatterbrained because I'm trying to explain so much and But essentially, everything's going to piece together as we learn more about SQL Server. But for now, just know that you can use the select statement to have the database give us back some data. But what we need to know now is how do we get data from tables? And that actually requires another keyword known as from. And we will talk about that in upcoming videos. So thanks guys, be sure to click subscribe and like this video, and I will see you in the next video. Hey, what's up world? It's Caleb from Caleb's Video Maker 2. This video we are going to talk about the create table statement in SQL Server. So the very first thing is you want to click new query. Now, the create table statement is used to create tables, obviously. So this video is going to walk you through that process and tell you everything you need to know to create a table. Now, the very first thing once you're in this query window is that you want to click this little drop-down box and choose the database that you are working with. The previous video, I created this database called Subscribe. You know, I gotta advertise, right? And that's the database I'm going to be using. So I click that. And then inside of here, I want to create a table for animals. Now, the command to create a table is actually very simple. All you literally do is say create table and then pick a name for that table. So we'll say animals. And then you put parentheses. Now, what are the parentheses for? Well, these are actually where the columns go. So I usually space this out and tab in. That way it's a little bit formatted a little better. And then each column I put on a new line. But before I do that, there's a couple things I wanted to discuss. The first thing is conventions. Conventions are these things that programmers follow to help them write more readable code. It's an agreed upon way on how to write something. SQL is very easy to work with in that you're allowed to type things basically however you want. So this create word, it could be create in lowercase, and it works exactly the same way. But by convention, I put it in uppercases. That's because, can't type. That's because that's what most people do. And that way, when I'm having a problem and I post my code online, people aren't like, what the crap is this? They can actually read my code because I follow a common convention. In addition to that, all database objects are written as Pascal casing. And what that is each word starts with a capital letter, and then the rest of the characters are lowercase. So for example, if we had 2 words, we could say animal profiles. And you can see that there's a capital for each word. So that's basically all I wanted to talk about for that. So let's move on to creating the columns. Now the very first thing I do is I think of the name of the columns. After that, I think of the data type for the columns. And then lastly, I think of any constraints for those columns. So let's go with the names first. We'll have an ID, and then I put a comma to say there's another column coming. We'll have a name, and then we'll have a species. So these are 3 columns we could start with, but we need to consider what data type we want each of these columns to be. I haven't discussed data types in a lot of depth, but I'm going to introduce you to 2 of the most common data types. The first one is int. Now an int is short for integer, and that means a whole number. This is used for numeric data and is almost always going to be used for the ID column. Now moving on to the name, this one's going to require character data, so string data. That means we need to use a data type like varchar, which stands for variable length character sequence. Well, it might not stand for that whole thing, but that's essentially what varchar is. The thing with varchar though is that we want to say how long we want the name to be able to be. So we need to give it a max length. So you need to ask yourself, what is the longest name I want to allow in my database? Now I'm going to use 50. I think that's more than enough characters for a name, and if your name's longer than 50 characters, you should get a nickname or something. You want to make sure you put that number within parentheses. Now I'm going to use the same data type for species. Later though, you could replace that with a foreign key to a species table. And what that would do is it would reduce redundant data and also help protect against mistakes. But for now, since we're just focusing on creating one table, I think that is more than good. Then we're going to want to end that with a semicolon, of course. This is actually all you need to create a table. It has all of the columns and has all the data types. Earlier, I mentioned constraints. Well, constraints are actually optional. So this should work if I run this create table statement. And you can see that it worked. And you can see it over in your Object Explorer if you go to Databases, Subscribe, Tables. Then let's try refreshing this. And you can see it right there. Now you can expand it and see the columns right here. Now you might be thinking, what about the constraints? Just because they're optional, we can't leave them out. They're important. And I would have to agree. It's always important to have a primary key. Because in this situation, we have an ID, but you can see it's labeled null, and also it's not unique. And therefore, it's really just not suitable as the primary key. So we need to go back to this table and add some constraints. That's what we are going to be talking about in the next video. Thanks guys, and I'll see you then. Also, please be sure to subscribe and click like on this video. Hey, what is up? It's Caleb from Caleb's Video Maker 2. This is going to continue your Create Table video for SQL Server. Now, so far, we are in the process of making this animals table. And you can see here, there's a little red squiggly saying this table already exists. So I already created this table. So that means when I run this command, it's not going to work. Oh, see, it didn't work. Like I said. Gosh, if you just trusted me. So now you might be thinking, how in the world am I supposed to change this darn table? Well, you can't just go in here and change things. For example, this was originally 50 and I changed it to 30. Well, that's just not going to work. So there's 2 options on how you can do this. The first is alter the table, and then the second is drop the table and recreate it. Altering the table is a little bit more complex, and that's actually something we are going to cover in a lot of depth in the upcoming videos. But for now, I think the easiest way is to drop the table and recreate it. So the term drop means to delete. So we are just essentially getting rid of the entire table. This is different than just deleting the data in the table. It's going to delete the entire thing. So what that means is all of your data in the table is going to be utterly destroyed. So make sure you look through the data, make sure there's nothing important, and if needed, you can back up the table or whatever, but we'll deal with that in another video. We don't have anything in this table, so it's not essential that we worry about the data. So the command to do this is very simple. All you say is drop table animals. Now the thing here is that we want to make sure we're talking about the right database. You can see here this is on master again, which is kind of annoying that it goes back to that all of the time, but just make sure you are on the correct database or things aren't going to work out right. So we are going to drop this table. That's all you have to put. You don't have to put parentheses or pass anything into this. You can think of it as just a modification of the create table because it's kind of the same. Create table animals, drop table animals. So let's run this. And it works. And now that's going to allow us to go in here and edit things. So we can make this 20 characters, for example. And you can see it allows us to recreate that table. So this is pretty cool. We can, delete things and recreate them. But now if we try to run this drop table command, see what happens. Oh, yeah, it's going to work because I just recreated the table. But let's run it again. Okay, there. It does not exist or you do not have permission. So now this is giving us a problem. So you kind of have to check to see if the table exists. You have to run this, and then if it works, you drop the table. If it doesn't work, then you need to create the table. Essentially, it's super annoying. It would be nice if we could do some kind of if statement saying, hey, if this table does exist, drop it. If not, don't worry about it. And that's actually very easy to do in SQL Server. All you got to do is go after this drop table and say if exists. That's literally all you have to do. So now I can take literally the entire script and just run the whole thing, and you can see it works. And if we drop that table and then run the whole thing again, you can see it still works. So what's going on is it goes here and it says drop table if exists. It checks if it exists and it doesn't, so it doesn't drop it. And then it moves on to the create table. So that is how you can do that conditionally. That'll improve your scripting and you don't have to worry about executing sections like this or having errors show up here annoyingly. That's all, guys. Hopefully that was helpful. And in the next video, we'll be covering something pretty delicious. So I will see you then. Thanks, guys. Oh, and be sure to click like and subscribe. Yo, welcome back. In this video, we are going to be talking about primary keys and a couple other constraints and how to add them to the create table statement. The reason being is because we have these columns in here, but we haven't told SQL Server which one's the primary key, and we haven't really described any of the columns in any detail. The very first thing I want to do is start with the primary key. But first, I'm going to change this back to varchar 50, and that way everything's back to how it was. Now the column we want to be the primary key is this ID column. And there's a couple different ways you can add constraints, but one of the easiest ways is to add them as a column attribute. So when you have an attribute, it describes the column. And we put these right after the column. And you don't use commas or any kind of punctuation. All you do is put a space. So it's really simple. Just go after this int right here and say primary key. Primary key. There we go. Oh, there we go. That's literally all you got to do to say it's the primary key. But the downside to just leaving it at primary key is that it's not going to automatically generate new numbers. And the way to do that is to say that this is the identity column. And you can also see that when we have multiple attributes, we can just separate them by spaces. As well as that, when you say primary key, it's automatically going to be not null and unique. But we might want to add some of those attributes to some of the other columns. For example, this name here, we might want to say a name is required. So to do that, you can just say not null. Same for the species. Another attribute we can use is unique. The thing is, here we don't really have a good column to use this attribute on, so let's add another column. We'll add an email address for us to contact this animal or the animal's owner, if that would be more appropriate. So we'll just say contact email. And we'll need to add a comma after the previous column. And for this one, we'll say not null and unique. And obviously we're going to want to throw in a data type here too. We'll just go with varchar 50. Now something about emails is that emails can actually be longer than this, but in the practical world, most emails are going to be way under 50 characters. So if you make a larger varchar, you increase the probability of people putting fake, huge emails into your database. So generally I think 50 characters is just fine. Now you can see that we've described a lot of the other stuff in this table, and the table becomes a lot more like what we imagined when we were designing this. So let's run this and just make sure everything works fine. Okay, commands completed successfully. Now let's go to our Object Explorer and see how these things show up. So let's go to Databases, Subscribe, Tables, Animals. And you can see all the columns right here. You can see that this is the primary key. That's what that little key symbol is. And you can find all of our attributes right here. Not null, not null. The unique actually goes in the keys. So unique key right there. And then there's the primary key as well, which is the same as this one right here. So that's a pretty rough introduction to column attributes and how to use them. There are some other attributes you're going to want to use eventually, including foreign keys, default, which is actually going to give a default value if you leave something out when you insert data into this table. And then there's also an attribute known as sparse, which can be used for nulls. So if a lot of the data for a column is null, you can use the sparse attribute and it will help save storage. But we will talk about all that in the upcoming videos, so don't worry about it for right now. Just focus on what we did here, and in the upcoming videos, we'll be adding some more to this table, and everything will go well. So thanks guys, and I'll see you in the next video. And as always, please be sure to click like and subscribe. Hey everyone, welcome back to Caleb the Video Maker 2. This video we are going to be continuing off of the last video. So in the last video we created this table animals. And you can see here one of the columns here is species. Now this column is going to give us some problems. And the reason that is because all we are is storing the species as plain text within a varchar column. That means if we have, I don't know, 2 million animals sign up for this app we're working on, well, in that situation, we might have the same value for the species 30,000 times. So you can see that the data becomes very redundant. Redundancy is one of the leading causes of anomalies, so we want to get rid of all redundancy. And the way we need to do that is actually turn the species column that's varchar into a foreign key referencing a species in another table. So how do we do that? Well, we actually have to have that other table created. Now, when you reference a column from another table, you have to label it as foreign key. Sorry guys, my dog keeps sneezing every time I try to talk. Now, when you reference a column from another table, the column that is being referenced is known as the parent. The column that's referencing it is known as the child. Now, when you create these tables, you always need to create the parent table first. So in this situation, the species is going to reference another table. So this would be the child. We need to create that parent. So I'm going to put it up here. We will just say create table, and then we'll say species. And the columns we are going to put in here are the ID. That's going to be an int, primary key identity. The next thing we're going to add is the species. And this is going to be essentially the same value that we would have stored here. So we can even copy that data type, varchar 50. And we are going to make this not null and also unique. It's going to be unique because each species needs to only be in this table one time. And then we can have unlimited references to that individual species. Additionally, I'm going to make a column for now called friendly name. And essentially that's going to be a friendly name of the species. So if you have a family, genus, species kind of thing, it's not exactly the most easy thing to read. So this could be something simple like bunny. Now this could actually introduce some redundant data here because, there could be 20,000 species of, maybe not 20,000, I don't know. There could be 20,000 species of bunnies and the friendly name is bunny for all of them. So the solution to this would be to make some kind of animal categories table and then we could reference that with the foreign key here. But for now, the amount of redundancy is nothing compared to having this species column down here. So I'm not going to worry about it right now. So what we need to do is give it a data type, and we'll just say varchar 50. And we are going to make this one not null, but we're not going to make it unique because we just said we will have redundant data in here. Multiple species could all have the same friendly name. So overall, this looks pretty good for the species table. I'm getting an error here, I think probably, yeah, so I was dorking around with this at one point, so let's just add this drop table if exists. Now, what about this table? We actually need to replace this column with a reference. So the very first thing when you're creating a foreign key, you need to make sure that the data types match exactly. So what are we going to be referencing? Are we going to be referencing the species column of the species table? Or are we going to be referencing the ID column of the species table? Well, you could do either one because this is labeled unique, but in general, it's best to reference the ID. So that means we are going to change this to species ID, and then the data type needs to match exactly. So this needs to be an int. Now we created the column, but how do we tell it to reference this column over here? Well, we just add a couple words right here. It's real simple. References. It's one of the hardest words to type. And then you say species, and then in parentheses you say the column ID. So everything should be good. We just have to make sure to switch this to the right database, of course. All right, let's run this and make sure everything works. Boom, there you go. That is how you create a foreign key in SQL Server. Thanks guys, hopefully that was helpful. If you like this video, be sure to click like and subscribe to this channel. And I will see you in the next video. Yo everyone, welcome back to Caleb the Video Maker 2. So in the last video, this is where we left off. We are in the process of creating an animal dating site, and we have a table to store all of the animals that sign up, and a table to record all of the available species. And then the animal can reference one of these species. But you know, that's really not enough for an efficient dating site. The animal needs a way to say other species that they are interested in, right? So we need to create an interests table. Why do we need a third table? Well, it's because one animal can be interested in multiple species, and an individual species can be labeled as an interest from multiple animals. Therefore, we have a many-to-many relationship. And you know, many-to-many relationships don't go well with databases, so we break this up into two one-to-many relationships. So this becomes an intermediary table. And this kind of breaks that tension between the two tables. By now, you're probably an expert on the create table statement, so I'm not going to waste your time explaining it all. But now I'm wasting your time talking about how I'm not going to explain it all. Oh. And the two columns in here are literally just going to be a species ID and an animal ID. That's because we are associating one species with one animal. We'll start with the animal ID though, because an animal is interested in species. It just makes more sense to put it that way. You could flip it and say, here are the animals interested in this species, but this is more clear to me. And then we are also going to have the species ID. Now, what data types are these going to be? Well, as you learned in the last video, the foreign keys always need to match the data type of the column we're referencing, which means we need to make these both int. We are also going to make them not null, but we are not going to make them unique because that would defeat the purpose of this table. The point of this table is to allow an animal to be interested in multiple species. But if we made the animal unique, for example, then we could only have this animal in this table one time, which would limit the animal to only one species. So each individual interest is going to get one row. That means an individual animal ID might be in here 20, 30, 40 times, depending on, the character of the animal. Now, what about the primary key? Well, we've talked about this. There's two ways we could do a primary key for this table. The first is to have a compound primary key. The second is to create an ID column. And this would be a unique ID to describe a specific interest. Now, these both have their ups and downs. The ups for the compound is that we don't need to add any columns, but the downside is that it becomes more complex. Anytime we want to talk about this individual interest, we're going to have a compound foreign key, which that just makes things more complicated. The benefit of this column is that we can avoid that. Now, when we reference an individual interest, all we have to do is have an individual ID as the foreign key. To expand our learning, I am going to go with this route. So we are going to create a composite primary key. Now, how do we do this? We can't just add it to a column like this. That's because this is a column level constraint. It can only talk about this individual column. So this is a problem. We actually have to add the constraint at the table level. So that means we add it as if it's its own column. So we just come past here and add a comma, and then we just say primary key, and then in parentheses we can actually add both columns. So we could say animal ID, species ID. So that is how you create a compound or composite primary key. Last thing, I wanted to add a drop table statement for this table. So let's go up to the top. And one thing about the drop tables is you always want to try to delete the children first. Because, for example, if we try to drop this table, here, I'll show you. You can see it says it's referenced by a foreign key constraint. That's because we didn't use the onUpdate clause when we created this foreign key. That means we need to try to delete all the children first. So this new table, it actually references both tables. So it's like the child of all children. So we need to drop it first. So let's add a line here, drop table if exists. Interests. All right, so everything should be good. Let's run it and make sure it all works. And there you go. Now let's go to our Object Explorer and find that database, subscribe, go to the tables, and then go to interests and then columns. You can see that they're both labeled the primary key. But if you go to keys, you can see it has this Disgusting name. It's just gross. All right, we need to fix that. So in the next video, we are going to learn how to name our constraints. So yeah, guys, thanks for watching. Hopefully that was useful. If you need to look over this, here's the entire code. And yeah, thanks guys. I'll see you in the next one. And be sure to subscribe. Sup YouTube, it's Caleb from Caleb the Video Maker 2. In this video, we are going to be talking about naming our constraints. So I'm an idiot and I forgot to do something important in the last video, and that is make these columns foreign keys. So we will do that in just a moment, but for now, I wanted to talk about this primary key. And if you go to the Object Explorer and expand that database, we'll go to Subscribe, Tables, Interests, Keys. You can see there's one primary key, and we talked about how disgusting this name was, and we want to change that. That's what we were going to do, and then I'll talk about naming foreign keys, and that's when I'll put the foreign keys on the other columns. So this is at the table level right now, and you can see it's right here, and it's very easy to add a name. All you have to do is add the constraint keyword and then give it a name. Now, what do you name it? Well, that is up to you ultimately, but there are some conventions. There's something known as Hungarian notation. And what that is where we put what the thing is inside of the name. So for example, we could say PK underscore and then give it a name. And that PK is a prefix that says what the thing is. Some people like this, some people don't like it, some people prefer at the end. That is ultimately up to you, but I'm going to follow this convention for right now. So I'll say PK, and then I will put the table name. So that way we know this is the constraint for the interests table, and specifically it's a primary key constraint. You can figure that out just by reading the name. So let's run the script. I'll make sure I am on the subscribe database because I forget that every stinking time. And now let's run this. All right, and you can see that it executed successfully. So let's go back to our Object Explorer, go to Keys, and refresh. There you go. You can see that it's nice and beautiful. Now let's talk about how to do that with foreign keys. It's very similar. We're going to put the foreign keys at the table level. So I'm going to start right here, and I will say constraint, give it a name, FK underscore. Now what are we going to name it? Well, we will name it the first table, so interests, and then the second table, which is the table of references. So interests, and this one is going to be for the animal ID, so I'll say animals. Then you have to say the constraint type, which is foreign key, and then you have to say what column it is on in parentheses. So this is on the animal ID, and then you have to say what it references. First you put the table, so it'll be animals, and then in parentheses you say the column. And there you go. You can see this is a little bit more long than the primary key, but overall it's not too complicated. Normally all you have to do is put references animal ID up here with the column, but if you want to put it at the table level, this is what you need to do. Let's add another column for the species ID. It'll be pretty similar. And there we go. Now let's run this and make sure everything works. Awesome. Let's check the Object Explorer, do a refresh on our keys. And you can see these foreign keys have such beautiful names. Why do we care that much though? The reason is that when we try to insert data into these tables and for some reason something's incorrect, it's going to give us an error and say the constraint name. And if we have these nice beautiful names, it's much easier to figure out what constraints it's talking about. And we will talk about that in the next video when we learn about the insert statement. So hopefully you guys are enjoying these videos, and I'll see you in the next one. And as always, be sure to click subscribe and like. This is Caleb from Caleb the Video Maker 2. Peace out. Man, my outros just get longer and longer every time. Welcome back everyone to Caleb the Video Maker 2. This video we are going to be talking about the insert statement. So this is a very good milestone in SQL. We've talked about all the create table garbage, and now we're moving on to putting data into those tables. Now, what are we going to do with all of this junk though? We want to keep that. So what I want to do is save it as a script. So you can click File and save it. I obviously already saved it as animal dating site, which that works fine for me. Now I'm going to actually create a new script by clicking New Query. And then I'm going to save that. This will allow us to have a level of separation from the stuff we use to create the tables and then the stuff we use to insert data into those tables. So the insert statement, as you may have guessed, it starts with insert. And then we have to say into and then put the table we want to insert data into. Now before I start typing stuff in here, we need to figure out what table is the most parent of them all. So let's go back to our create table statements. You can see in here we are creating the species table first. That's because the other tables are going to reference this table. It works the same way with rows. We need to create the parent rows before we create the child rows. So let's go back to our insert statement, and then we are going to say species because that is the table we need to start with. The next thing you do is use the values keyword, and then in parentheses you pass in values. This is going to require you to know what columns are in this table. So the easiest way to do that, if you do not have this available, is to go into your Object Explorer and then find that table, species, and then click columns. We have an ID, species, and a friendly name, int, varchar, and varchar. So let's put some data in there. Let's go with one, this, and then the friendly name, which will be bunny. Notice that we separate each value by commas. Here's a comma. And here's a comma. So just like when we create tables, we separate columns by commas, the same thing happens when we are inserting data. So to go over these, this is the ID, this is the genus, and this is the species, and this is the friendly name. Now you might look at this and say this is a violation of things being atomic. That's because we are storing the genus and the species inside of one column. But you know, YOLO. Oh, great excuse. Just don't say that if you're at a job and they ask you why you did something. Please don't say YOLO. Anyways, let's insert this. But wait, I wanted to show you something. You can actually get rid of this one here. And that's because that is the identity column, and it will know that we want to automatically generate a value for that row. So let's run this thing. 1 rows affected is the response. So now we can go into our Object Explorer, find that species table, and then we can right-click it. You can see that there's 2 options. Select top 1,000 rows and edit top 200 rows. So you can click either one. And you can see the data pops up and it automatically generated an ID for us, which is 1. So that's pretty cool. Now let's go back to our query, and we will end that with a semicolon. And now this is the perfect time to show you how foreign keys help protect our integrity. Let's try inserting data into the animals table. Insert into animals, values, and once again we don't need the ID, but we do need to know what columns go here. So let's go to our Object Explorer, click animals, columns. We need an ID, skip that one. We need the name, the species ID, and the contact email. If you want, you can dock this, so that way you can see it as you're working. So let's go through these. First one is ID, which we can skip. The next is the name, which we will say is Sally. Then we will give it a species ID, which we will say is 2. And then finally a contact email, which is going to be this. Now note, strings start and end with a single quote, and numbers do not have quotes. Let's run this little section and see what happens. And you can see here, there is an error. The foreign key protects us from inserting invalid data. You can also see here that the constraint name shows up. That is why some people like to name their constraints, so when an error is thrown, they know exactly where to look. So a lesson you can learn from this is to always use foreign keys. Now, what if we want to insert 2 values at one time? Let's say we want to insert 2 animals into this table. Let's try that. But first, I'm going to correct this ID so it'll actually let us insert some data. But the way you do it is just put a comma after this, and then you can put more data in another set of parentheses. So I'm going to break this down to the next line just so it's a little easier to read. We will say Franklin, and maybe someday we can add a ID for turtles, but for now we'll just use a rabbit. There we go. Now we should be able to insert both of these values at one time. Let's execute this, make sure it works. 2 rows affected. So you can see that they were actually both inserted. And the way you can see this is by right-clicking the animals table and clicking Edit Top 200 Rows. You can see here we have Sally and Franklin, and the IDs were automatically generated. Note that the ID of 1 is not in here. It's perfectly okay to have missing numbers for the IDs or for them to be out of order, as long as they're all unique. So that is all for the insert statement. If you want one last look at it, here it is. Nice and beautiful. So thanks guys for watching. In the next video, we will be talking about something even cooler. So thanks guys, I will see you then. Also, be sure to click subscribe and like. Sup everyone, it's Caleb from Caleb Video Maker 2. This video we're going to be talking about the select statement. This is one of the key statements in SQL, so you want to pay attention. The way it works is very simple. All you have to do is say select, and then what you do is say the columns you want to select. That ultimately depends on what table you're going to select from, but let's select from our animals table. So let's go over to our Object Explorer and expand that table to see what we got in there. Subscribe, tables, animals. We can look at the columns here. We will start simple and we'll build our way up. So I'm going to select the ID, name, species ID, and the contact email. And then say from, and say what table you want to select this from. Animals. Let's run this and see if it works. Great, it works. You can see it returns all of the data that we want to see from this table. As you can see, the syntax is really not that hard, but there's actually some things we can do to make it simpler. The first thing, rather than going into our Object Explorer to see what kind of columns we have in there, what we can do is we can prefix each column with the table, and it will tell us what columns are available. Here, I'll show you what I mean. Let me erase this. We can say animals, dot, and here are all of the columns that are available to us. So this makes it super easy for us. The way you want to do it is ultimately up to you, but I'm just going to show you that this does work. And then let's run that. And you can see it works exactly the same. In this situation, we are selecting every single column. There's actually an easier way to tell SQL Server we want everything, and that's to replace all of these columns with an asterisk. And you can see it works just like normal. Additionally, you can put expressions in your select statement. So let's undo that, and I'll show you what I mean. So let's say instead of having the contact email followed by the name in two separate columns, we wanted to put that in one for easier reading or something like that. What we can do is literally just put plus signs to do what's known as concatenating. So we can take animals.contact email plus animals.name. And this is going to be returned as one column. That's because there's no commas to separate the columns. Additionally though, we are going to want to put a quote in here with a space, maybe a hyphen, and then another plus. That way it just looks a little prettier for us. Let's try this. And there you go. You can see that it says Sally at calebcurry.com -Sally. So that is your introduction to the select statement. Hopefully that was nice and juicy. Oh goodness. My outros. If you like this video, please be sure to subscribe. And as always, click like. I will see you in the next video. Hey everyone, welcome back to your 30-second SQL Server tutorial. My name is Caleb from Caleb the Video Maker, and this video is going to cover aliases. Now an alias is a name you can give something to refer to something. An alias is essentially an alias for nickname. Oh, you see what I did there? When you give something an alias, you can refer to it by that new name you give it. Why would you want to do this though? Well, there's two primary benefits that I can think of. The first one is if you have a complicated name and you give it an alias, whatever it is, it'll be easier to refer to it by that new name. The second reason though is that it can actually improve our presentation. So for example, these columns down here, we can change the names of these columns. In the last video, I talked about concatenating data, and I'm going to do that in this video, and then I'm going to give that column an alias so the presentation looks a whole lot better. So right now, I'm just selecting everything, but what I want to do is I want to select a new column that I'm going to generate, and it's going to be a combination of the person's name and email. So we want to select animals.name plus, and then in quotes, a hyphen, plus animals.contact email. All right, let's run this. And you can see that it returns the data with this nasty column name. So an alias allows us to replace that no column name with something specific. And the way you make an alias is with the as keyword. And then you say what the name is going to be. So let's give this column a name contact. And now let's run this. And there you go. So if you need to present some beautiful data to your boss so you don't get fired, what you can do is give all of your columns an alias, that way it can explain exactly what they're looking at. You can also do this for other columns, it's not just for generated columns. So for example, we could also return animals.species ID, and then we could say species ID. Now in this situation we have a space, so I think we need to quote this. Let's run it. And there you go. This allows us to decomputerize our data and make it a little bit more user-friendly. Now, aliases are not just useful for presentation. They can also be useful for us as developers. For example, we can give an alias to a table, and then we can reference that table by that new name. In this example, we are working on an animal dating site. So essentially, each one of these animals is going to be a user in our site. So we could rename animals users if we wanted. And it's just for this query, so it's not actually changing the table at all. And now when we type that out, you can see a bunch of things turn red. That's because we have to address it by its new name here. Select users.name, users.contact email, and users.species ID. Now the entire query is going to give us the same results. So what exactly is the benefit here? Well, if we have a super long table name, for example, we can shorten it, and then it's easier to reference it. Or when we are doing things such as joins, it just makes life a lot easier because we can shorten our queries down a whole lot. Some people like using aliases, other people think it adds a layer of confusion. The decision is ultimately up to you and the people you're working with. So hopefully everything you learned in this video will come in useful for you someday. Even if you're not using aliases yourself, I can guarantee you at some point you're going to come across this as keyword. So now you know what it means. So thanks guys for watching. Hopefully you've enjoyed this video. Please be sure to click like and subscribe to the channel. Thanks guys, I'll see you in the next one. Hey, welcome back everyone. In this video we are going to be talking about indexes. Yeah! Now we've briefly talked about indexes in this SQL Server tutorial series, but in the upcoming videos we are going to be creating these indexes, so I thought it'd be appropriate to, go a little bit more in depth with these things called indexes. It's been a little while since I've made a video, so it might take me a couple seconds to get back in the rhythm of things. Also, I apologize ahead of time if I throw up because I've been sick for like a long time. But that's enough about throw up because no one really wants to talk about that. So let's get on to indexes. What is an index? Well, in databases, an index is when we tell the database we are going to use this column or a group of columns for a bunch of stuff. It improves the speed of our database. Essentially what I'm saying is that we create a column index. Now that SQL Server knows how to treat that certain column because we labeled an index, it improves the speed of our select statements and also joins, which are part of select statements. So literally, the easiest way to think of an index is to think of a book which has an index. So an index is something usually in the back that you can look at and it'll tell you where they talked about certain topics. Of course, the one book I grabbed does not have an index. Anyways, pretend that the back of this book has an index. And what that index does is it lists different topics that the book talks about and where to find those topics in the book. It works similarly in databases because we can define a column as an index and then that database knows how to grab that data quicker. Now there are two types of indexes when we are working with SQL Server, and those two index types are clustered and non-clustered. I'm going to give you a rough overview of what both of these are, that way you are prepared to make legit indexes on your database. The essential difference between these two is how the data in the index is structured. The first one we are going to talk about is clustered. Now, I don't know about you guys, but back when I was a young lad, we had these things called phone books. And what these things do is they list phone numbers of, all the people in your local town or your city. Now the way these phone books are organized is that when you look someone up, all of the information about them is right there. So let's say the phone book is organized by name. You could say that the name is a clustered index in that phone book. So in databases, clustered indexes determine the way the table is actually laid out. To better think this through, let's go through a simple table to see this. Here is a table, and we have an ID column and a name. Very simple table. Doesn't really matter if it's useful for anything. The thing you're going to notice here is that these are ordered by an ID. So in this situation, we probably put a clustered index on the ID column. The names, on the other hand, they are in no particular order. That's because they don't have an index. So if you were to tell the database, yo, give me the dude with the ID of 3. Well, it's easy. All you gotta do is go down to the ID of 3. Boom, right there. But if you say something like, yo, give me the person with the name Mark. Well, now the database is going to have to go and scan through every single row to try to find Mark. So you can see that it can be much more time consuming. When the things are in some logical order, the database can find that data much quicker. Now moving on to a non-clustered index, it works very similar in that it organizes the data like this, but the actual data that's associated with it is stored somewhere else. So it kind of just tells you how to find the data. The best illustration for that is using an index in the back of a book. So let's say I look up something like joins in a database development book. It'll say joins, page 4082. It points you to where the data that you're looking for really is. So let's say we wanted to order the first name. We could put a non-clustered index on this data, and the end result would be something like this. You can see that these are in a procedural order now, and if there is any other information associated with this row, for example, a last name, since this data is in order, the database can find the data much quicker. So you could say, yo, give me the person with the last name of Mark. Boom, right there. Then it is easier for the database to find the data relating to Mark. And there you go, there's Mark Smith. So another way to think about it is that the non-clustered indexes organizes the data, but does it separately than the way the table is actually structured. The table is actually structured by ID here, but the database does some additional work of keeping some kind of system of ordering for the names. Then the database can use that system to find the data related to that name or whatever the index is on. Now indexes work the best when you're grabbing the data that is indexed. So what that means is that if you have some kind of index and you are selecting data, it'll probably be faster if you just select the columns that are part of that index. But that doesn't mean you have to do it that way, and generally indexes can help with a lot of things. So if you're running into the problem where your queries are slow, you'll probably want to look into adding indexes. And in fact, you should probably design your database to have indexes to begin with. So what do you want to index? I know this video is kind of running long, so I'll try to keep it simple. Essentially, you want to index anything you're going to commonly use for a select and also joins, which we will discuss joins in more detail as time goes on. So this generally includes the primary key, which by the way, anything labeled primary key is going to be a clustered index by default. So you usually do not have to worry about the primary key. The next thing you'll want to consider is any foreign keys. If you're using joins and you're joining foreign keys to primary keys, you'll probably want to make a non-clustered index on those foreign keys. Lastly, the third type of thing you're going to want to index is any other columns you are continually selecting. So if you have some website that continually selects the same data and over and over and over again, you might want to consider adding an index on there and seeing if it improves the speed any. The last thing you guys need to know is that you can only have one clustered index. Only one. And why does that make sense? It makes sense because this determines the table structure. You can't have the table structured in one order and also in a different order. Only one index can determine the order. You can have as many non-clustered indexes as you want. I mean, there's a limit, but in general, the number of non-clustered indexes is not a concern. The only concern you might want to have is that the more indexes you have, the slower the database becomes. That's because anytime you update data or insert data, it's got to update it in all of the indexes. So for example, let's say Mark changes his name to Mark with a C. Well now, this has to be updated in all of the indexes referencing that column. So there's a good balance. And obviously this is a lot of information for one video, so we can't cover it all. But this is a pretty good overview, and in the next videos we'll be creating indexes in SQL Server. So thanks guys for watching, and if you like these videos, please be sure to click like and subscribe, and I'll see you in the next one. Thanks guys. Hello everyone, welcome back to Caleb the Video Maker 2. This video we are going to be talking about creating indexes in SQL Server. Now, in the previous video, I discussed the concept of indexes. So if you're really unfamiliar with them, you'll want to make sure you go back and watch that video. But if you have a rough idea, this video will be fine for you. It's not going to be too complex or crazy or anything like that. So right here on the screen, you can see the tables that I've created. And we need to think what columns would benefit from an index. But the very first thing we should know is that some columns are indexed by default. And those columns are any columns labeled primary key or unique. So you can see that this column is going to be indexed, this one, this one, this one, and this one. So we really don't have to worry about a whole lot, but there might be a couple other columns that we want to pay attention to. And the ones that usually jump out to me are foreign keys. That's because we use foreign keys for so much, but we often neglect them in that we don't give indexes to them. And remember that we want to give indexes to any columns we're going to continually use for joins and also for selects. What that means is that foreign keys are basically perfect candidates for indexes. The column I am specifically interested in is right here, species ID. It's a foreign key referencing the ID of the species table up here. The reason I want to index this so bad is because once we have all of our data in the tables, we will often want to select all of the animals and list the species name, not just the species ID. But the species name comes from this table up here. And in order to do that, we have to join the tables. That means we're very often going to use a join on this column. So let's open a new query so we can make some indexes. The syntax is very simple and probably pretty familiar to you once you understand how the create table works. The way we create an index is with create index, and then we give it a name, just like in create table we give a name. Now, what do we name it? That's ultimately up to you or your boss, but I'm going to follow the convention of ix underscore and then whatever I want to name it. So the ix is a prefix that stands for index. So whenever you see ix, you automatically know it's talking about an index. The next thing I'm going to use is the table name that the column is located in. So going back to our other page, you can see that it's in the animals table and the column is species ID. So we are going to name this animals and then species. You could name it species ID if you want, but I think this is fine. But this here is not enough. We have to tell SQL Server what table and what column this index is going to be on. So we can go down to the next line and say on animals species ID. So the column goes in the parentheses and the table goes after on. Let's run it and make sure it works. And there you go. Now occasionally it's going to come up where you need to delete an index. And the way you do that is you say drop index. So drop is the command we use to delete. Then you say the index name. This alone is not enough though. You actually have to say what table that index is on. So the way you do that is say on animals. And you can see that it worked. So the syntax is very similar to the create index. The only thing different is that you don't need to specify a column because that index already exists on that column. Additionally, you can make indexes on multiple columns at one time, and this is going to be a combined index. It's not a bunch of individual indexes on each column. It's one index on multiple columns. So for example, if we go back to our structure, you can see in the animals table we have a name and contact email, and we might use that a whole bunch. So let's say I wanted to make an index on that. Here's how we do it. Create index, and we could just say animal contact on animals, and then in here we put in both of the columns. Let's try it. And you can see that works. Now, when you have indexes like this, it adds a layer of complexity, and that's something we are not going to dive into right now, but that is something we may address in future videos. The last thing I wanted to mention is unique indexes. So if you have a column that's always going to be unique, you can use the unique keyword. So for example, we could do something like this. Now in this situation, we are telling the database that every single species in the species table should be unique. So let's go back to our structure. You can see this right here would have to be unique. And it's actually already labeled unique.